Vada, and Instack Kolkata. Our event today is centered around the theme steel, the choice of material for sustainable development and green buildings. As we gather here, we are not just participants but contributors to a crucial conversation about the future of sustainable infrastructure and green building practices. We are honored to host a distinguished panel of experts, each bringing a wealth of knowledge and experience to the table. Their insights will undoubtedly shed light on the pivotal role that steel, as a versatile and enduring material, plays in the development of sustainable infrastructure and in pushing the boundaries of what is possible in green building design. This seminar promises to be a significant learning experience, offering fresh perspectives and innovative ideas that can help us all contribute to a more sustainable future. Before we embark on this journey of knowledge and discovery, I would like to take a moment to express our deepest gratitude to our platinum sponsor, InterArc Building Products Limited. Their generous support has been instrumental in bringing this event to life, and we are sincerely thankful for their commitment to advancing the cause of sustainable development. In addition, I would like to extend a warm thank you to all the distinguished guests who have taken the time to join us today, as well as to our esteemed audience, and we are thrilled to have you with us. We will now commence the inauguration session with the ceremonial lighting of the lamp, a timeless tradition that symbolizes the victory of light over darkness and the beginning of a new journey towards knowledge and wisdom. I now invite Dr. Vijayalakshmi Karthik, the director in charge of SPA Vijayawada, to lead us in lighting the lamp. I also welcome all the dignitaries present on the dais to light the lamp. kindly request all the dignitaries to be seated onto the dais. We are pleased to welcome Shri P.K. Mishra, sir, the Director General of INSTAC. With over 30 years of experience in steel marketing and a previous role as a board member of NALCO, Shri Mishra leads INSTAC, a non-profit organization established by the Government of India and major steel producers. INSTAC is dedicated to advancing steel technology through standardized bridge designs, improving vernacular housing with steel frames, and developing cost-effective design methodologies. I now invite Sri P.K. Mishra, sir, to address the gathering virtually.
Sir, is it me?
Sir, you can now address the
I'm
gathering.
not able to hear anything. I am not able to hear.
Sir, you're audible, sir.
So can I speak now?
Yes, sir, yes.
Also, I am prepared to speak right now, huh?
Yes, sir. Please do.
Okay, because there are some, I am not able to hear anything whatever is happening there. Anyhow, I am speaking now. Okay? Okay. Am I audible, madam?
Yes, sir. You are audible.
Okay, thank you. Uh, uh, can I start right now?
Yes, sir.
Okay. Good morning to all of you. Dr. Vijay, madam, Dr. Srinivas Baketi, Dr. Venkat Sadhu, the faculty and other faculties from SK Vijayawada, our distinguished speakers, Dr. Siddhar Reddy, Dr. Gopal Krishna Rao, Dr. Anchuri, and others. My apology that I could not physically attend the program there. I really wanted to go there, but in fact my younger brother has undergone a major operation yesterday, so I am in Bhubaneswar attending to him. He is in hospital ICU, so I will be now again going to attend to him. But I thought it is better to interact with you over VC. Last year, we had a similar program in SPO Bhopal. Eminent architects like Dr. Habib Khan, Charanjit Shah, Nikhil Filawala, they had all attended the program. We got an idea from that event that there is a need to engage more with the architects and students of architecture with regard to usage of steel in construction. That is why we have organized this program also. In fact, our institute has been, holding a all India kind of competition every year for architect students. But this kind of workshop, this kind of direct interaction with the students is something which we felt it is necessary to increase the awareness of the students of architectures or architects about each other's field in construction. My colleagues should be telling more about INSTAC. INSTAC is an institute which is almost 28 years old. This is promoted by Government of India and other major producers of steel like Tata Steel, JSW and Steel Authority. Please visit our website to get details about our institute. I will not take much time to explain the activities, but we are seriously engaged with the stakeholders with regard to how we can augment consumption of steel in this country. Today, the per capita consumption in India is hardly 95 kg, whereas the global average is about 223 kg. China, with whom we get compared every now and then, their consumption is about 645 kg per capita. Japan, Korea, they are all ahead of us. Whereas we are the number 2 producer of steel in the country, in the world. In, construction, despite the fact that steel is more environmental friendly, steel is durable, steel is recyclable, and steel also has different aesthetic value in terms of construction. So this kind of gap which is existing between what steel is really is, how it can be made better use of, and why it is not happening in industry or construction. That is something we have to identify, and this kind of workshop is going to help. I urge the academic, community to kindly examine this aspect, and in our assessment, whatever little assessment we have done, because we have been working very closely with IITs, we have been working, we have also made a teaching resource material for structural engineers, students of structural engineering. We are also in the process of making one manual, that kind of teaching resource material for architects. That is what the idea Dr. Habib Khan had given. And with the help of IIT Roorkee, we are trying to make that document. The idea is how steel can be better used if it is not being taught in the curriculum, in academic curriculum, how it can be taught more, or at least in the workplace, in place of actual construction, how steel can be better used. So with this few words, I would like to take leave. I would have been happy to present there, but this is a very serious subject, and for the students I will only request that you have to consider skill as a very important option for your career, because today skill may not be that important in your eyes, but tomorrow when the advancement takes place. We were in Japan 6-7 months back along with some of the IIT professors and one professor of SP Bhopal. We found almost everything. Surayati Chanda, who is present there, he also had gone there, that same thing. Everything is made in steel. Everything. You will not find even small gardens they have made in front of the house, that is also made in steel. Everything is made in steel, and you will not find any kind of other construction material like concrete or wood or any other thing in a place like Japan. If you go to any other advanced country, you will also find all kind of common objects of common use are made in steel. So there is a need for learning about steel, and students of structural engineering, students of architecture, they have to purpose know this. If they are not knowing through their own academic curriculum, they have to take separate interest and they have to learn it. INSTAG is also conducting some certificate course. We have started with IIST Shibpur. We are also planning another one or two more course along with ACRC Chennai and some other IITs. In case you have any ideas how we can be more useful for the academic community or students community or professionals, please give your suggestions. And I request that please follow us, please get associated with this non-profit. We are not a profit organization still in the country. At the end, I thank the sponsor, Interact Solution, for having supported us, and I also thank Dr. Shiv Prasad, who has taken immense pain to organize this program. And I again thank SPA Vijayawada for having given this opportunity for conducting this knowledge sharing event in your premises. Thank you. Thank you, madam. Please allow me to quit.
Thank you, sir. Before we commence this interactive session, let us extend a warm welcome to all the dignitaries and speakers present here today. I now request Mr. Shiladitya Chanda, sir, to present the bouquet to our Director in Charge, Dr. Iyer Vijayalakshmi Kasinath. This will be followed by bouquets being handed over to Dr. Venkata Krishna Kumar Sadhu and Dr. Janmajoya Gupta.
Hi, sir. I will quit now.
Sir, please do hand over the bouquet to Dr. Venkata Krishna Kumar, sir. Followed by Dr. Janmajoya Gupta. Thank you, sir. I now also request Dr. Srinivas Daketi, sir, to present the bouquet to Mr. Sridhar Reddy. I now invite Dr. S.P. Anshuri, sir. Yes. Thank you, sir. Thank you, sir. Last but not the least, I now request Engineer Rishabh Datta to present bouquets to Dr. Uma Shankar Basina, followed by Engineer S.V. Gopal Krishna Rao. I now invite S.V. Gopal Krishna Rao, sir. Thank you, sir. Our key patrons have been instrumental in fostering a platform for the exchange of innovative ideas. Firstly, we are honored to introduce Dr. Vijayalakshmi Kasinath, Director in charge of the Department of Architecture, With extensive experience as a faculty member, Dr. Kasanat specializes in sustainable built environments. She has played a significant role in Solar Decathlon India and contributes to the Council of Architecture subcommittee working. Yes. Thank you. Yes. Yes. Dr. I now request Dr. Srinivas Taketi to present the bouquet to Dr. S.P. Anshuri. Thank you.
A very good morning to one and all. On this occasion of the technical seminar on steel, the choice of material for sustainable development and green buildings. On behalf of our director, Dr. Ramesh Rikunda, who is not here because he has an urgent disposition at Delhi, I'll be in charge and hence I am here. On his behalf, on behalf of SPAV, I would like to welcome Mr. Sheeladitya Chanda, Mr. Sridhar Reddy, Dr. S.P. Anchuri, Engineer Rishav Datta, Engineer S.V. Gopal Krishna Rao, and our own Dr. Uma Shankar Basina. It is a special honor to be associated with Sri P.K. Mishra, Director General of INSTAC. Now, as someone with an interest in sustainable architecture, I know that greenhouse gas is the major element that we are fighting today in order to reduce the global warming. Greenhouse gas emissions originate from various human activities. Notably, the highest producer of greenhouse gas is energy production through fossil fuel combustion for electricity and heat generation. India's post-2020 climate goals includes a target to reduce the emission activity and its intensity by 33 to 35% from 2005 level at 2030. And also, we have made a commitment to the world that we would go carbon neutral or net zero carbon by 2070. Globally, the building sector accounts for about 30% of global carbon emissions, and at least 8% of this comes from the manufacture of building materials. Materials with highest embodied carbon values are typically those associated with energy intensive manufacturing processes or carbon intensive raw material extraction. While these specific numbers, it can vary depending on factors like region, transportation, production methods, etc. And steel is one such material. Now, having played the devil's advocate, let us also see how steel can be a sustainable material. Because steel's natural characteristics makes it a great sustainable choice in terms of its almost endless recyclability. The ability to future-proof structures to be modified or extended later. So even in retrofit, steel can be used as it was manufactured. They are robust, durable, and reliable. All forms of steels are recyclable. The recycling rate of steels depends on the end use, but on average, about 85% of steel is recycled globally. Steel is one of the most recycled materials in the world because of its 100% capability to be recycled, meaning it can be melted down and reused without degrading in terms of properties or its performance. Through closed-loop recycling, every ton of the scrap recovered can replace 1 ton of primary steel making. It is environmentally beneficial and economically smart to recycle scrap steel instead of using new materials for manufacturing process. A case to this point is the shipping containers. Extremely strong and durable, which withstands the saline environment for months together and yet is as durable and strong. Steel is it has longevity and durability compared to other building materials. It doesn't take much structural steel to hold a building up as compared to some other material. The majority of structural steel contains high levels of carbon, but even stainless steel, galvanized steel, or mild steel can withstand large loads. All types of steels are strong and durable. It's an extremely versatile material. We use it even in our pressure cookers as well as for buildings. So it's an extremely versatile material. Its recyclability is the what shall I say, biggest USP, which fights against all the odds that it does to the environment. Therefore, it is even termed as a low carbon dioxide emission material. Besides, one of the most important characteristics of steel, which most sustainable architects fight, is it does not emit any harmful chemicals or toxins. So I hope today's session covers a wider range of justification to accept steel as a highly sustainable material. My best wishes to all the participants here, the speakers, the coordinators, the co-coordinators, and the student volunteers in making this seminar a grand success. I hope at the end of the day, we are convinced completely that steel is a 100% sustainable material on par with any other material and would not be classified as an energy intensive material. Thank you.
Before we begin the enlightening session, let us all stand for the national anthem. I kindly request everyone to rise. With this, now we have reached the end of our inaugural session. We will move on to our first presentation. It is my pleasure to introduce Mr. Sridhar Reddy, the Chairman and Managing Director of Sri Harsha Consulting Engineers Private Limited. Mr. Reddy is a highly accomplished civil engineer with a specialization in geotechnical engineering from the Regional Engineering College, Kurukshetra. With over 3 decades of experience, he has been instrumental in the design and execution of various projects, including power plants, government hospitals, and landmark structures such as NTR Gardens and Ramoji Film City. His leadership and expertise have made him a prominent figure in the engineering field. Please join me in welcoming Mr. Sridhar Reddy to the stage.
Yeah. After the confirmation from Mr. Sridhar Reddy, let me also announce that he has designed one of the recent landmark buildings, that is Telangana Secretariat. I think that got missed in the introduction. Welcome, Sridhar.
Yeah, good morning. Good morning, sir. So, all SPA team, thank you very much for inviting me. Good morning, INSDAC team. Thank you for inviting. So, all structural engineers, architects, students, everybody, welcome. Thank you. Steel structure design under challenging conditions. Yeah, today I have my team also. Hello. 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 Huh? Yeah. Okay. Yeah, today I have my team also present here. So I'm going to present this with a kind of, we'll start with a smallest demo to the structures. All of you, a journey, how we can, it's a fun in structural designing, how it can be fun doing the steel structures also. So I'll request my team members to bring some props from there. So I just wanted to give you a demo of each of the piece so that everybody can understand what the structure is. So I used to tell my staff member also, one of the staff member, Mr. Bhimavaram, I just give you that sentence. Mr. Bhimavaram, you should go into the beam and bend like a beam. Then only you will get the behavior of the beam. So everybody, this is structural engineering is a more of a perception than a engineering. First of all, how it behaves, we should perceive the things. Then only we can design a better structure and economical structure. Why economical? I'll tell you. So to be totally responsible in designing the steel structure or any kind of a use for the steel, because the amount of effort in making the steel, that means bringing the ore from the earth, and there is a too many laborers are involved, each and everything they bring it, process it, they'll make all this kind of a steel for us to use it. So each one of us should be responsible, as madam told just now. That's a sustainability. That means we have to be more responsible. That is also, we have to be more responsible. That is also very important. We have to be more responsible using the steel. So that is the reason we have to understand the structural stability first. How the structure can be used. How the structure, we have to design economical version also. So behavior also we should understand in a better way. So now you can see this prop. Okay. This is a column placed in a minor axis. This is a major axis. Okay. We'll just try to load it. Then it will bend. So there is a movement in the column. Since it is in a minor axis, so it can bend very easily. You can see visually also there's a bend. Okay. Now columns are placed in a major axis. The span also increase. Now if you load it, then visually you see it's not bending. So it means you have to see the structural system, how the orientation of the columns has to be there. Then people can understand better way. So our responsibility from the industry, from the teachers. So we have to make students understand how the behavior of the structure. Okay. Now we are given one single column, right? Now we are trying to do two columns. So if span is more, then what happens? Then there is going to be enormous movement on the column. Now introducing two columns, all the movement will be converted into the forces. Not exactly all the movement. Some of the movement can be like, when you are loading it, then the internal columns, it is a compression with bending it is going to behave, and this is a tension with bending it is going to behave. So in our case also, we are going to present the high-tech hall number 4. So I am just bringing you people onto the track, how we have taken and how we have analyzed the structure by understanding the structure in a better way. Because of the two columns, we have converted a compression with a bending. This becomes a tension with a bending. So we could able to design much better way. Okay, in our case, it is a 68-meter span. So 68-meter span, we cannot design with a single member. We should have a truss to support that. So making a truss, it is a bending on this direction, it is taking care. But it is weak in the other direction. So what to do now? So we cannot have a bending of it. So you can bring that bigger one. No, this is not bigger one. So by making truss, we are controlling the deflection because of the truss action. Now, finally, this is the model what we have done. Okay. Now the challenges. Okay. The topic, today's topic is structural design under challenging conditions. What are the challenging conditions? Okay. This is the first challenge is to create a column free space of 68 meters by 120 meters hall size. So this is a huge size. So somebody visited Hyderabad, they know there is high-tex hall number 1, 2, 3 are available. The seating capacity is 2,500 each. Now this, it can accommodate 8,500 people. 8,500, that's a huge space. Okay, not only that, they wanted a division of hall into 4 halls, 3 halls, 2 halls, depending upon the client's requirement. That means it could be a marriage function, it could be a car expo, or a JCB expo, or something, a helicopter expo also they can bring in. The reason is we have kept the height is 12.5 meters. That is more than 40 feet. That means it is suitable for all types of conventions, whether it is a pharma companies expo or any other companies. If they want to conduct an expo, they can utilize this. And a big fat buildings also it is possible. 8,500 people can be seated in one hall. That's a big hall available in Hyderabad. And the partitions, you can see these partitions. Partitions are hung from the rooftop. All these partitions. So this is one partition, 1 meter width is a 1.2 ton per meter. Just imagine we are placing everywhere these partitions. You know how much is the deflection? Just for the self weight of 120 tons. This is one lattice. This is a quadrilateral lattice, I can say. This one lattice weighs 120 tons. So with the self weight put together, it is that the deflection is 140 mm. After positioning this, nearly 80 mm is the deflection. That means we have to be very careful in designing. That is the challenge. Okay, creating a catwalk, anticipating the erection challenges, keeping a provision to avoid any untoward incidents. While erection, people make mistakes that we have to anticipate in advance. How? What we have done, we have given a camber in this. The upward camber we have provided 600 mm. The reason is, let us assume if this column in the erection, if it is going a 5 mm this side and 5 mm that side, then immediately the deflection will be for 50 to 60 mm. Then if we design in a straight manner, then it will deflect. For self weight, for this kind of a untoward incidents, I mean, even while placing also, I'll show you the video also in the later part of the session. So while placing this, we have given a slotted holes here. A slotted holes, after placing here, it is sliding by 30 mm this side. So that means we have to take That also into precaution. So 600 mm, that is the reason we have given. After that, we made a provision to make all the suspenders of with the steel members to suspend all these things. Total size of the building 86 meters by 120 meters. That is total size. That is pre-function area 12 meters by 120 meters. Grand hall is 68 by 120. Service area 6 by 120. Hall size is 12.8. So folded partitions are hung from the rooftop, and all these partitions can be moved. Main lattices spacing at 27 meters. Cross lattice 5.6 meter intervals. Structure designed for dead load, live load, wind load, and earthquake load also. So this is the basic plan. So that is the front portion is of pre-function area, and that is the bottom portion. And the top portion is 6 meters by 120 meters. This is meant for the services. Okay, next. Yeah, first floor plan. So there are mezzanine floors for the front portion. So we have created. In that area, they have all small parties, business conferences. They can make, organize. Second floor is also the same. Column layout. So you can see the column layouts. There are 4 number of columns at each location. So with these 4 columns, this is done in a steel. That's a box section of this steel is 450 by 750 this column. And this column also 450 by 750 we started, and we have made it tapered inside by up to 1200. Why 1200? This is a compression with bending. Steel is not good at compression. Compression with bending, we had to design with a 1200 width. This is a tension. Steel is good in tension. So the outer periphery columns 450 by 750 we made. This is tapered to the 1200. So compression with a bending, that requires a bigger size. So that is the reason we have designed like this. So 4 columns put together, it acts like one single entity to support this lattice as well as supporting the all partitions. This is lattices, and this cross lattice also 120 meters we need to move the partitions. Now this hall is having one column in between, right? So that is a hindrance for the people who are sitting in the behind. Now just imagine that kind of a seamless area people are enjoying, means that gives a immense pleasure. To support this, what we have given a triangular lattices. A triangular lattice, why triangle? Triangular lattice, it is a better way, it can have a bending on this direction, the out of plane bending also. So direction is also very easy. That is the reason we have given a triangular lattice sitting on these things. So this is the overall plan. So the 120 meters also. There's a partition walls. This is another partition wall. This is another partition wall. So they can make into number of halls, whatever the requirement. And all these partitions, when they want to use it as a single hall, all this 50% of it, it goes and stored here. And 50% it is stored here. That means all the partitions are hung from the rooftop. This room is going to support nearly 150 tons from the rooftop. We have to design for that. That is a challenge. This is the roof plan. This is the chart graphics. So for students who are well versed with the STAD and all, just imagine how much effort has been made to generate this kind of a STAD model. This is also a big challenge. And these are the construction stage photographs. You can see how important giving a camber, if any kind of a problem during erection, also it is taken care. So we should keep in mind while designing all these bigger spans or cantilevers, we should always keep that a camber for a cantilever, upward camber is very important. Yeah, can you run that video? You can just click on that, just see. Yeah, okay. Okay, actually, at the end of the session, we'll try to play the video also. And here you people have to think, okay, we have to give them a guidance for the erection contractor also. What if you place the slings only at the ends? What happens? The bending will be on this. So total structure will bend. So that is not our intention. If you place it only at the middle, those slings, then what happens? This becomes a cantilever on the both the sides. So we should guide them in such a way, nearly, we have calculated that also, nearly 25% of the span this side and 25% from this side, we have taken the slings and we have erected. So that gives the comfort while erection. So that is also a big challenge. Of course, inter people are here, they know better how to erect the structures for such a big spans. So this is the final outcome. Just you can see the size of the human being and the size of the hall. Yeah, I want all of you to have some deep breath so that we can go to next part. Can you bring that CPU? That's bottom one. Okay. This is a composite flat slab structure designed in steel and RCC. This is a data center what we have designed in Mumbai. So what the data center? People might think exactly what the data center. So all of you are using WhatsApp? Yes? Okay. You can take this. So data center, all of you are using WhatsApp, right? So all that is going to store it at one place. Where that place? In the data center. So what I feel personally, I don't use WhatsApp. The reason is, from my side, I should not give any a carbon emission because of just for me. So we have to be responsible while sending the messages to your people also. So just don't forward the things. The reason is, so it is going to create a lot of load on the data center. So why the data center is, so this is like a CPU, and this CPU in a, just imagine a bigger size. Okay, keep it there, no problem. So CPU is smallest size is this. But when you are storing in the data center, this resembles this. This data center is having a 600 by 1200 by 2400 is the size. But just to imagine, I just brought this, and those things are placed on the, not on the floor. They'll be placed 1 meter above the floor. Why 1 meter above the floor? So all the cables will be joined from below. All the cables will be joined from the below, and all the ACs are hung from the rooftop. So that means there's a lot of load. How much load? I'll go through the presentation. Okay, what are the challenges now? The design of structure to achieve the timelines. Control S Mumbai, we have designed in in 2008, I think, 2018. Okay, so the challenge was to design in a shortest possible time. The shortest possible time is only can be achieved through steel. So that is the reason we have, RCC can also be done, but the time is the essence of this project. The challenge was to design a structure by which the existing operation should not get hampered. That is also important. Limited space for storage of construction material. We cannot store too much of a scaffolding material there and start doing that. So that is the reason we have switched over to steel structure. Matching the existing floor levels, that is also important. Keeping the building 6.5 meters from the existing building, and they wanted that structure to be designed as a cantilever from this new structure. The design of composite steel structure for a huge load of 1.8 ton per square meter. That means 1800 kg per square meter. What is the load we take, live load for the residences? We take 200 kg. For commercials, we take 350 or 400, depending upon the client's requirement. But whereas this data center requires 1800 kg per square meter. Just imagine how much extra load we are going to give. That means one building, what we have designed for 12-storied building, it is equivalent to 50-storied building. The load is such that we have to design the foundations and the columns accordingly. Creating a more free area soffit to run MEP. If we can design a steel beams also, what happens? So there is a, very difficult to run all the MEP services. That is the reason what we have done, a flat slab. What in flat slab? Composite flat slab. And also, as I told you, this is a platinum rated structure. So to design a sustainable building by which renewable energy created through solar panels fixed on the elevation. Complete elevation is done with the solar panels. So they got the lead platinum data center, and it is the tallest data center available in the world. So this is a footing size for such a, and the best part of it is we got 300 ton per square meter SBC. This is a completely basalt rock, sheet rock. So they have reported 300 ton per square meter. We have designed all the footings with a 5.7 meters by 5.7 meters. That is the maximum size we got. Around more than 5,000 tons is the load. And the pedestal size is 2.1 meter by 2.1 meter. So the main columns we have designed as a CFT columns. CFT columns, you can see, this is a completely box made with a steel plates. And also we have given a ribs inside. 1500 by 1500. If you start doing the pouring the concrete inside, then it will bulge. So we need to have a ribs inside so that we can both the things. We can minimize the thickness of the plate as well as the when we are pouring the concrete, it won't bulge. And we have already placed the cage inside, steel cage inside, and we have they have supplied. Kirby has supplied with the cage. Columns have been supplied there. During erection stage, you can bring that. Okay, this model has been prepared in-house with my team members. I should appreciate all my team, and Ravindra and Stravani part of this team. 4-member team, they have created this and all the props, of course. So everything after this session, anybody can come and examine what the structure is, how it has been designed. Come. You can be here, no problem. So this is the main capitals what we have created, and in between thickness we have reduced. And what we have done, cantilever on all sides, 3 sides it is 2 meters, only on one side it is 6.5 meters because that existing structure is there already. Photos this. So we have provided a reinforcement at the bottom as well as the top, even for the capital area also. And the best part is to execute this. So providing a sheet below, this is one of its kind. Nobody has done it before. So we have poured the concrete from the top. Then it has become a composite. So fixing with this kind of a structure, it's a big challenge. Yeah. So capitals we have made with a I-beams 400 by, how much it is? These are the bigger size. 400 is the depth of the web, and a 200 by 12 or 16, depending upon the requirement. Flanges are there, and other beams are got connected to. This is only 200. The total slab thickness for this is 259, I believe. This is nearly 500. So this is the scenario. Which one? These are all, yeah. So we have provided they have provided into 2 pieces. Kirby has done this part, one part. This is another part. They have provided the extension of the members. So there they have bolted it. Yeah, this is completely embedded with a concrete, and also all around, and this is also filled with a concrete. That means it is a completely composite section. Providing a 6.5 meters cantilever is a challenge again. How we have achieved? We have provided the tension members by keeping a camber, upward camber. Otherwise, what happens when we are pouring the concrete, it will bend. So that is the reason this precaution we have to anticipate. Otherwise, then it's gone. So this is also challenge. Keeping a 6.5 meter. Once it's concreted, it's a composite section. The design strength will achieve. After that, it won't bend. This is during execution. program. Yeah, the timelines. I told you shortest possible time. 23rd June 2018, that is the stage. That is 31st October 2018, that is the stage. Hardly 4.5 months. So that means bottom level, nearly 5 floors, they have already laid the concrete, and the brickwork also they have started. They have given it for the interiors. This is the final outcome. Solar panels all around. This is the day photograph, that is a night photograph. So for better understanding, you can see the structure. There's a model what we have prepared. You can see and you can understand. So anything we can tell you later. And I want everybody to take a deep breath. We are going to another journey. That means don't think I am only giving the lecture. So some other person in your class with some other topic, they have come to explain you. Which one, sir? This is 6 meters. Each floor is 6 meters from the top. Which one? No. They have used the trimming. You are talking about the columns, right? They have used a boom placer. When we are placing this, so they have placed the boom placer and slowly they have taken out. So, I mean, it's not in a one go they place it. And also, yes, yeah, stage wise only they do it. And that is also, like, slowly they'll do it so that there won't be any bulging also. There won't be any segregation of the concrete also. Now this power plant PowerPoint presentation. Okay. This is the final outcome. So what are the challenges? Challenges is that is a MSW pit where this is a waste to energy. We have designed this project in collaboration of Telangana government. Ramki has executed this project. So all the waste and all, it will be collected and dumped at one place, and that from there they'll collect just adjacent to that. They'll pour all this, then they produce the power. That is the design of bag filter area, design of, and there is a challenge of 55 meters 55 meters unsupported length of the columns are there. That is also very challenging. How we have designed, we'll just go through that. It is a Jawahar Nagar in Hyderabad. Cost of the project is 500 crores. Important milestones also. During COVID, it has been executed. So it's a very challenging, tough time for them to erect also. So this is done by Karthikeya Industries. Total area is 120 acres. Size of the building is 148 meters by 72 meters. Total steel structure tonnage is 2,200. This is the total layout. This is a power plant total layout. There are segments, each segment. I'll just explain you. So they wanted a column free space in this area also. 41 meters by 65 meters. We have given only one single column so that all the girders we can make half the span. Design of a 65-meter span and erection is also very difficult. So we have provided a single column like this, and we have provided a jack beam there. On that jack beam, we have provided all the rafters, so that the rafter size has been minimized, and also erection was also easy. This is the scenario. Jack beam we have provided. And one more challenge, After this back filter area, there is a 55 meters gable end. How to support the gable end? So they have not allowed any columns in this area. So what we had to do, we have provided a vertical, bottom member is there, rafter is there, top member is there, rafter, and we have given all the verticals. This entire area, it is acting like a frame. It is not the bottom one, it is going to take the total load. It is a total, it is acting like a frame, then it is acting total structure. Otherwise, it is not possible. In this case, we'll have to see the load coming from the rooftop and the wind coming from the side. All those factors we'll have to account for. So this is a tipping hall. Tipping hall means, they'll bring the all the waste in the lorries and all. From there, they'll put all the waste into the MSW pit. And there was one more challenge of a box type elevation they wanted. Why the box type elevation? They don't want that to be look like a simple straight building. They wanted almost 5.5 meters in elevation to be increased so that it looks like a box. So how to design a elevation then? Then we have to provide a member on the edges so that it won't bend. What we have done, if you carefully see, there are one member like this, another member is connected here, and this is the elevation member. So when wind is acting on this side, okay, so this will be under tension, this will be under compression. When wind is acting on this side, it will be under tension, this will be under compression. Otherwise, only with a single member, if you start designing it, then it is difficult. All the movement has to be designed for that movement. This connection becomes very difficult. Now it has become only shear connection, not the movement connection. So this is the tie beams also. Tie beams also we have provided with a lattice only, 4-member lattice. Otherwise, that's a big column we cannot support. This is another view, cross section. Roof plan. This is the stat graphics. You can see what is the total height difference from one end to the other. You can see this area I was talking about 55 meters. This is also 55 meters. So supporting this column, the other side is not connected, only at the roof only it is connected. This is the unsupported length of the column is 55 meters. This is 22 meters. This portion is MSW pit. I'll skip this. So this is the during construction. MSW pit. That is almost 15 to 20 meters below the existing ground level. They started. This is the counterforts with a RCC wall. You can remove this. Elevators. Elevators. No problem. This is the ash pit. Just look at the photograph. The person standing is almost 6 feet, and the column size is also 6 feet in the width. 1200 by 1800 column size. This is the scenario. So entire thing is not 1200 by 1800, uneconomical. So we have reduced the column sizes also. That is the splicing detail. We have to be very careful while doing the splicing also. Everybody has to design the splice. Just like that, splicing is not possible. Back filter area. 55 meters column erection. That is the biggest challenge. But Karthikeya Industries, they have done wonderful job. So during COVID also, they struggled a lot. They have completed the project within the scheduled time. This is a bird's eye view of the total project. So, organize, I just wanted to ask you your permission whether I can continue this portal renovation or yeah, you can. Okay, thank you. So because and this is another, you can take one more deep breath. I I went to one hotel. So I stayed in a hotel room and they were doing some renovation work. Like, they were removing the false ceiling in one of the rooms and doing it. I asked them, why? So they told every year they have to renovate it. The reason is there is a huge deflection. The span of this thing is 23 meters. 23 meters, each year it is deflecting. Anchuri sir, it's a classical case of failure. You also do a lot of this thing. Okay, so what happened? Then I asked them, what is the problem? Then I went to the one of the floor. It is a 6 meters height, and there is a visible cracks in the center, and the deflection also 80 to 100 mm. And the bottom ground floor is a banquet hall, running a banquet hall, and they were not able to push the partition walls. Each year they are cutting the bottom portion. Then only they could do the this thing. Run the banquet hall. The challenges. So this is I told you 80 to 100 mm is the deflection. We have to restore it. How to restore it? Ground floor is a running banquet hall. First floor is a again empty hall, and upper floors are all rooms. We cannot place any scaffolding material anywhere in the building. And the rooftop is a solar panel. Rooftop solar panel. We cannot go and do something on the rooftop also. How? Then we want, that's a 23 meters. That earlier structure engineer, he has designed only with a 525 mm depth of the beam. So that failed. That's a pity, of course, but that's failed. This is the scenario. You can see that visible a camber also there. Downward camber. What we have done, the columns are, good. 400 by 1000. Columns are very well done. We have checked the foundations. We have checked the columns. The adequacy is enormous. So what we have done, we have made holes in the columns. And we have provided that kind of arrangement. Why that kind of arrangement? We could have done straight away the lattice, right? The reason is placing that a lattice moving inside, it is a very difficult. That is the reason first we have done, it's a composite section with a steel plates. I have attached on the both the sides. You can see that attachment. After that, I brought that span has been reduced so that the movement of the lattice we could able to do that. Then we brought them inside from the other side, back side, and from a very short openings were there. From there only people have struggled to do that. They brought in, they are fixed. And that is the final after the finishes of everything. So not only the design, we can do renovation of buildings. If there is something failure is also there, we can do with the help of steel structure. So This is not at all possible with the renovation work with the concrete. If you want to add more concrete to that, then it will collapse immediately. If you have to add more concrete or more reinforcement, where do you place the supports? Supports is also very difficult to place. There is no area to support. And after finishing this, and one more bigger thing I have to tell you, the upper floors, we have provided the floating columns in the room areas so that upper floors have been supported. And the bottom floor, when we went to the after finishing, they were able to move the partition very freely. The reason is, it is no more, it is bending like this. It has taken the shape because of the elastic nature, slightly it got retained that shape so that it relieved the space in between. So that the banquet hall at the ground floor, they could operate the partitions very well. And the upper floors also, all the floors are supported with the floating columns. And now they are removing the, I told them, the columns are adequate. I told the colloquially, one more floor is also possible, sir. Why don't you? I mean, it is very easy. Now they are doing one more floor with a steel structure. That's a secret. They have already started. Thank you very much. Students must be having a lot of questions. And one more thing I'll tell you, this is only seed what I am trying to give you. So you may apply in your course of time during design stage and all. So it may be utilized in course of time, maybe after 5 years, 10 years. This information is available to you so that anytime you can apply this. Not necessarily you may get tomorrow itself, but all these challenges are inevitable in your career. So please, anybody? Yes. Yeah.
Yeah. May I know what are the reasons for that deflection in that floor?
Yeah, that is because the earlier structure engineer has not anticipated what he thought. That's a PT has been designed. So that PT beam failed. Because of the PT, it did not collapse. Otherwise, with a 525 mm beam depth for a 23-meter span, obviously you will not get that kind of risk. It's a huge. That's the reason it got deflected.
Is it due to corrosion of the reinforcement steel?
Nothing.
Okay.
It's only design failure.
Okay. Thank you.
So can I conclude then? Yeah. So you can also, we can interact after the session also. Any questions? You can write it down. So any questions?
Hello.
So we'll try to answer. Right?
Hello.
We also have a panel discussion at the end of the day. So if you have any question, you can also reserve that and put that question during the panel discussion. All the panelists will be there also. So it is your choice. You can ask now or you can reserve the question at the end of the day.
Acha, one more small thing. There are 2 videos are available on the projects. So if you can, it's only 1 minute. I don't want to make you wait much. So can you please run those 2 videos? sound also is there.
Come 2019, the processing and disposal facility at Jawaharnagar dump site would present a green and lush landscaping. But was Jawaharnagar dump site always this aesthetic? Far from it. An estimated 1.2 crore tons of waste was accumulated at the site before starting the treatment and disposal facility in 2012. Due to public unrest, the entire waste generated in the city started getting diverted to Jawaharnagar. Greater Hyderabad Municipal Corporation, formed with the merger of 12 surrounding municipalities with Municipal Corporation of Hyderabad in 2007, started dumping the entire waste generated within its jurisdiction of 625 square kilometers at Jawaharnagar. To address this issue, GHMC conceived the Integrated Municipal Solid Waste Management Project to comply with the Management and Handling Rules 2000 to be implemented through public-private partnership model. Hyderabad Integrated MSW Limited, HIMSW, was selected through an international competitive bidding process as concessionaire.
I am Ayodhya Reddy, a civil and environmental engineer. My engineering in civil and my specialization in environmental engineering, working for the first 5 years with Gannon Dunker Lee and Company, started Ramki Group in 94-95, the first generation entrepreneur hailing from Guntur district of Andhra Pradesh. 84 to 94, those learnings have made me realize that there is a need for an EPC and a consulting company in these areas of civil engineering and environmental and waste management sectors.
HIMSW, after receiving environmental clearance and other permissions, started the treatment and disposal operations at Jawaharnagar on 18th February 2012. It has adopted a combination of mechanical and biological treatment and thermal incineration technologies for treatment of waste. Biodegradable waste, or the compostable fraction of waste, is transformed into city compost, and the combustible fraction, comprising largely of non-biodegradable percentage of waste, is converted to refuse-derived fuel, which is used as an alternative fuel in cement plants. Rejects generated during the process are landfilled in a secured engineered landfill, and leachate generated is treated with a high-performance PNT reverse osmosis system. To establish the treatment and disposal facility, HIMSW has shifted the waste strewn at Jawaharnagar site into an area of approximately 110 acres, reclaiming over 200 acres of land. The reclamation of land and capping of old dump site are progressing briskly and are expected to be completed by mid of 2018. Once capped, the entire site will look very aesthetic. Jawaharnagar facility, which is operational since February 2012, has a capacity to process 6,000 tons per day against an average current waste receipt of about 5,000 TPD. HIMSW has undertaken to construct a state-of-the-art waste-to-energy plant at Jawaharnagar using the reciprocating pusher grade technology, which is to be constructed in an area of 30 acres. Once commissioned, the plant has the potential to reduce the waste volume by up to 90%, with only 10% by volume going into the landfill. Hyderabad city has been ranked first in the country in terms of treatment of disposal compliance with the Swachh Sarvekshan surveys in 2016 and 2017, and combined efforts of GHMC and HIMSW. HIMSW as its backbone is committed to transforming the Jawaharnagar treatment and disposal facility into a center of excellence for municipal solid waste management and dedicating it to the mission of Swachh Bharat.
one announcement for the students. Uh, there will be a cash prize for the best essay writing. There will be a cash prize for not essay in the sense you need to give one page report by the end of the evening. So the best report for this session would be given the cash prize. So this is announced by Mr. Sridhar Reddy.
For now, let's take a short break to recharge. We will have a brief tea break and request everyone to reconvene at 11:45 to resume the session. Uh, for the dignitaries and faculties, tea will be available in the auditorium. Students are requested to go outside and have tea. This is also a reminder that all UG and PG students must compulsorily attend the seminar until the very end. So be back in 10 minutes. See you all. Thank you.
Hello. 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 Hello.
Hello.
Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. Hello. It's okay. Okay.
All the students are requested to please come back to the auditorium. We will resume with the seminar. Can I have everyone's attention? Everyone is requested to come back to the auditorium. We'll resume with the seminar. I repeat, please come back into the auditorium. We'll resume the program. I request everyone to please be seated quickly. We'll resume with the seminar. Everyone who is outside is requested to come into the auditorium. We'll resume. I repeat, I want Could everyone please settle down quickly? We'll resume with the seminar. Our next speaker is Dr. S.P. Anchuri, a renowned artist, architect, and structural engineer. Dr. Anchuri holds multiple graduate and postgraduate degrees in civil engineering, architecture, architectural engineering, business administration, structural engineering, and construction management. He also has a PhD in structural engineering from Jawaharlal Nehru Technology University, Hyderabad. As the chief consultant of Anchuri and Anchuri, he has designed over 1,500 buildings with a unique blend of architectural and structural design. Dr. Anchuri is an ECBC expert and the first third-party assessor for ECBC in Telangana and Andhra Pradesh. Please welcome Dr. S.P. Anchuri to the stage.
Good morning, ladies and gentlemen, boys and girls, and respected teachers. By saying, oh, very good. Now, almost all about 20% or 22% of the audience, they're gone. Anyway, good. So actually, I wanted to have a column-free space and hands-free audio system, but somehow it's limited to the podium. But by seeing all of you, the professionals and then one side students, I'm a little scared. So now I'm feeling some stage, fear. So with your permission, I will come down. Thank you. Am I audible? Friends, we are sitting absolutely below the classrooms, isn't it? Below little at ground level also. And you have gone through first presentation of very, very heavy spans, tall, long columns. But somehow we need to get rid of this column. Mr. Harsha, if anything is there to remove this, or we need to shift from here. That's the story. Friends, what is that? That particular thing comes, huh? Otherwise, that part will be always not be there. Slide changer. Let me set for 1 or 2 minutes to have the flow. Neither this is a technical presentation purely, nor this is a classroom. And excuse me, this part of the hall where my expert and more than my expertise, people are sitting here. So this is made mainly for the students. So please try to be attentive for some time. I would like to take you or travel along with you in the world of steel. Now, anybody likes the better performance, isn't it? Efficient structures. So I chose the building or built environment which gives lot of efficiency or which is high performing, and SPA Vijayawada naturally with good performance you will be entering here, isn't it? So the techniques, the technologies which are involved, keeping steel in mind, I think that is my topic, but I will take you through some other journey where, as an architect, I understand to build the space or create the space, we start from the planning, isn't it? So we heard about earlier speaker, excellent, but after seeing your movie, I didn't come to know who was the director of the movie, who was the writer of the movie, who are the actors in the movie, rather than your complex solving techniques. But architecture starts something in a different way. That starts from the mind of architect, isn't it? And we conceptualize and you help us, isn't it? So we never understood why that was long span, why that failed, why the steel was used, why concrete was not used. See, it's not, it's an integrated approach, isn't it? So I need to have some kind of understanding why really this comes in, why Instack is there, why they're not promoting steel, they are promoting one kind of a structural system, which is most efficient compared to others. That's what we want to see. See here, some people are that side, some people are this side, excuse me, but both the screens I will try to utilize that. So here, human evolution. When we started about 2 lakhs years back, isn't it? Now when we started, what was that time? We started from the caves, isn't it? And where we are now, formless construction. Oh, we have 3D printing. What is 3D printing? There is no form or form work is involved. They can print like this. In Telangana or in Andhra Pradesh, we have sakinalu, or chakli. What is that? It's a 3D printing. What we are doing? Chakli jab banate ho, jalebi banate ho, na? So are you comfortable with Hindi? So when you are making some kind of a jalebi, what is that? You have some kind of ingredient, some machine to make that, and the process. So today we are talking about 3D printing. It's not new. We need to bring the old to our things. How we started? So we started from the caves, and today we have robotics. In fact, somebody asked how you are pouring the concrete. So manual or manual mix or mix design or whatever it is. So today we have robotics also in the construction. So we are almost all in the world of new generation. But friends, we need to understand where we are going. Today the generation is different. We are thinking of only generation or coming up generations, but we need to think of regenerative architecture. I think the regenerative architecture with the generative engineering is the need of the hour, and where the steel plays a vital role. In fact, one of the material which is sustainable, but how to use it, we must understand where the compression comes, where the steel, tension comes, where the torsion comes, where the shear comes. And for architects, believe it or not, the moment you say bending moment, they start bending. The moment shear force, they will be shearing, Friends, nothing to do with this. We have people like Mr. Sridhar Reddy for design. We need to plan it out. We need to say that this is my requirement. I don't want this column. Before he came, I was just suggesting either we shift somewhere or shift the column. And you can do it. So anyway, so what is regeneration? Say for some, say you can just see that happened, that fire happened, and after 2-3 weeks again it will come. So do you go to jungle to pour the water? Do you add any pesticides there? No, it's a natural. So we need to understand what is the built environment, why architect can't create some built space which is like a forest. See, we need to come to the nature, but today's nature of the people is going away from the nature. That's the result, isn't it? So here, today we are the era where AI is dominating or going to dominate. And yesterday you heard Mr. Ambani, I don't know where we are going to do. He is creating artificial brain. You are going to ask some kind of artificial brain which will solve you and everybody. So, ab tak to kam se kam kirana shop mein immediately, without calculator, they were using entire calculation, but I don't know. So where our intelligence will go. But here, how that AI gives, one of my friend's son, who was doing, playing a lot of video games in the childhood, always I used to scold him. Arey yaar, aapke papa dekho kitne achhe buildings banate hai. So he said, no, uncle, I will also be in this line. And after 20 years down the line, just 2 months back, he said, uncle, I have created Hanuman, the movie Hanuman, the virtual. So he's into virtual reality. It doesn't mean even so-called the super hit movie Kalki. He has done some part in that where he's not creating physical buildings, but virtual physical buildings. So if you have that ambition to go to that particular thing. So I think HI, the human intelligence, AI, the artificial intelligence, but we need to have NI. What is that? Natural intelligence. So we need to go to the nature, understand it, and then for me, any building is a tree, isn't it? So tree is a cantilever, building is also a cantilever, isn't it? So how that acts when I was saying yesterday, he brought those, thanks for, first time I saw the speaker carrying entire his wagon, samples. I used to carry small. The moment I saw my sponge models and other thing, I kept in the car. So I couldn't bring because they are bigger than that. So hats off to you. So in fact, when he brought those samples, it had all lateral resisting system and it passed through. Because when you are coming the car, so you might have experienced that and your model stood for that. Thank you. So the another thing is, you can see all these AI images, what you give input in terms of whether it's a STAD model, whether it's any CAD model or any software output, input is very important. So the architectural, if you give input, that is going to give you entire thing, right from the plan, right from the elevation, right from the materials, right from the everything. But really, it is going to help or not, that we have to see. So one of my friends from Romania and Tunisia, they are doing this. We never heard even those countries' names, but the people in the remote, they are developing this AI, just imagine. So after post-pandemic, it has become a global, which is now local, isn't it? So here, you can see in the very field, how the AI, so something, if you can give a sketch that is developing like this. Now, friends, architecture, you know what is architecture? Architecture is the art and science of designing buildings and other physical structures. And that comes in our mind when you put paper and pencil. So today you are directly using tab and gadgets, but still okay. But that comes from the brain. But don't allow only AI or somebody's brain and come through your hands or your things. But so you need to understand. So for me, I compare the building body to the human body, isn't it? So believe it or not, everybody sitting here has a same hand, eyes, ऐसा कोई है? कोई physically challenge हो सकता है, but उसको उतने ही joints है जितना मुझे है, उतने ही eyes है जितना आपको है. So visibility is different, but we have different efficiencies. He may be more efficient than me in terms of, because he has not built in one day. It may be food. He's a vegan. He has his own limitations. So you need to intake, have exercise, build your body, then the life cycle, isn't it? Leave about the accidents and all. But other than that, I can maintain my body, do the design life if really it's accordingly. So here, the structure, yes, when he talks about the structure, whether it's a steel, whether it's a composite structure, whether it's a concrete or hybrid, but we need to have some kind of a structural system which in turn assembles the elements and gives the stability of the structure. That is their job, to understand architecture and give that particular thing. Now, today we are talking about the complex built forms. That may be auditorium, that may be a hospital, that may be hospitality, that may be sports, that anything. But we need to understand, the architect has to understand the function and then the building services. That's what some challenges we are facing in this particular hall. We are saying that this is a seminar hall, but it's a temporary setup. I think I saw another one. And next time I will talk there also. So their audio maybe a little better. If I show the Bahubali or Kalki in this particular screen, I think your sitting arrangements will be different, isn't it? And your attentiveness also will be different, because that's the requirement. Now, friends, anyway, when we started thousands of years back, we had a master builder, isn't it? Who was an architect, who was a structural engineer, who was a geotechnical engineer, everything all in one. Taj Mahal or whatever you take, ancient structures, the one person was called as a master builder, and he used to undertake everything, integrate everything. But today, it's different scenario. For left eye we have one doctor, one right eye we have one doctor, within eye we have about 30, 40 types of doctors, isn't it? So there are so many experts, and we hardly go to the physician, isn't it? Maname decide chestam. Not even you go to AI and you put something, it will scare about something, and then we try to even take treatment. I don't know what is the future of that. But the structure, there are about 300, 400 types of structures. It's not one or two. Say, even elements, the fan. The fan is having some structure, stool is having some structure. So structural systems are different. So here, based on the application, based on the structural system, forms, materials, elements and types, we can divide that. But here, we need to focus on the material, which is steel, and which is good, as per me, in some cases, if you go for properly designing, that we will be talking today. Now today we are talking about conventional, green, sustainable, restorative or regenerative, but friends, be in a regenerative design, because that is going to be the future requirement. Now, for any work, whether to conduct a event like this, whether to go or plan some kind of a going to a movie in the afternoon, or anything in our life, we need to have some kind of a Mahapanchabhutas, elements of Mahapanchabhutas like this, which is feasibility, starting point of the project, functionality, space used for what, technology, engineering of buildings, endless options, the sustainability need of the time, and innovation, design, shape, and construction. But as per me, the correct is beauty, but beauty is not always correct, isn't it? If somebody is very well dressed, very smart, it doesn't mean that he's having good attitude, isn't it? We need to understand. So don't go with the only facade, and people in the market or people in the society, they think that architects are only made for aesthetics. No, that myth we need to erase it off. Because we are everything comes on, it's like a story writing. It's not everything, isn't it? That's what I said, all in one, and then everything comes next, like expertise. So we need to understand that. So these are a few projects which we did. Some are in steel, some are in concrete, some are in composite and all, but there are few to some mythological. And we do a lot of convention centers, we do a lot of different variety. And if for an architect or structural engineer, the built environment makes no difference, isn't it? We can create temples, we can create anything. So one of the creation is Ramanarayanam, which is in Vijayanagaram. We conceptualized this about 15 or 18 years back. and this is one of the noted structures of our family. Now, design is to design, a design to produce a design. Here, I would like to thank SPA Vijayawada and INSDAC who took the responsibility for bringing me here. But there is one negative side of that. You know, Mr. Sridhar Reddy is a very tough guy, isn't it? Now, when somebody goes to him for employment, naturally, it's not that easy, isn't it? Now, when that Sunil goes to Mr. Sridhar Reddy, and when he comes, then naturally you will be interviewing, isn't it? Now, he is a very, very down to earth, but very, very different guy, isn't it? You saw him. He asked that Sunil that, are you sincere? Are you dedicated? Are you responsible? If you are okay, then I will take it. Then that Sunil says, yes, I am very sincere. And I am very much dedicated. And above all, I am very much responsible. Then Mr. Reddy asks, why you are emphasizing on the responsibility? He said, मैं इसके पहले कहीं पे भी काम करा, everybody, for anything that employer was to say, you are responsible. कुछ भी करो, you are responsible. So here, SPA, Vijayawada, and INSTAG is responsible for me. If something goes beyond, I don't know. Anyway, it's time to create the living future. The post-pandemic, we thought of the life will be different, isn't it? And it's there. What's different? Nothing is different. We were neglecting everything. We were ignorant of the things. In fact, what we had, we never thought. No, Americans will say Yoga Day, then we will say that, oh, today is a Yoga Day. Or Suram Namaskar, they will talk about that. The importance of Tulsi, they will talk about that. Importance of washing our hands and legs, they will talk about that. The Western culture, if something goes from here and comes back, then we will think. So we need to create our living future. And for that, friends, the building envelope plays a vital role. Definitely it plays a vital role because this particular presentation can go for 3 to 4 hours, but I have only 30-40 minutes to cover, so I will be little speeding up. If I put some kind of a hot beverage in this plastic bottle, it will have its temperature for how much? 10-12 minutes, the same, isn't it? But if I want to keep this for about 4-5 hours, I need to use flask, isn't it? Which has insulation. Like a refrigerator and like an almara. There is a difference. I can't keep the same thing in almara. I can't keep ice cream in the thermocol box, which gives about 4-5 hours, same thing. But if I keep outside, within 10 minutes, gal jayega, isn't it? The enclosure is very important. Here, the building envelope is very, very important, where we need to think of the skin. Today we are thinking about tall buildings. If you see all this information technology buildings or whatever upcoming glass boxes, whether they are energy efficient, whether they are following those norms, keep it aside the structural glazing system, keep it aside the requirement inside, but we need to understand something more than that. But steel structures definitely give us ease to design the facades in a better way, which is energy efficient and also a sustainable one. So here, the moment I say building envelope, I have a roof, walls, windows, foundation, and which comes in a different shape, but the basic is this. So here, the weather barrier, air barrier, thermal barrier, alien barrier, and the structural systems. We need to understand these things, and while planning itself. So, believe it or not, this entire exercise we do as an architect before really it goes to somebody, but when I design this thing, everybody will be on my board, isn't it? See, about 15 to 17 domains or experts will be sitting together to have workshop to how to conceptualize. It's not just do everything and go. And you may be experienced in your thesis work how to go about it, isn't it? So we need to understand all these things. what is the system and how the system will be becoming efficient. So better envelope is always good to have a sustainable design. So there are so many advances, there are so many techniques to make these facades more sustainable. You can see the snapping facade. This is a very, very old, you have seen, isn't it? Fan, huh? Visnakara. So if you see the structure of that, and if you just extend that, so how this is? So here, the technique is there, but you need to adopt that, isn't it? It's a very different type of structure here, which is more of a passive, but passive in addition to active, that becomes, so here, if I have steel structure, it will be very much easy to adopt these techniques to apply and implement. Now here, bend and pull. See, we play with umbrella, isn't it? I think you remove the tensile fabric, I have an umbrella here, and play with it. Sometimes when you go in a wind, it gets reversed. So why? So we need to understand. So we need to understand. At this age, you need to analyze, explore, and how it can be utilized in a better way. That we need to understand. He gave some chamfering. It's a very, very simple thing, but he gave in a major structure, isn't it? Because you understand the behavior of that. So we need to understand. And being an architect, they are in between artist and engineering. So you need to be more careful about the things because you need to join both together. So this is what the things develop. And naturally, friends, whether it's a steel building or whether it's a composite building, whether it's a concrete building, we need some kind of a form, isn't it? The form follows function, but function follows human behavior today. It's not earlier days. We need to understand if something is looking good or excited, the people look, because it's a requirement of, So bridal dress is different. My dress, I know that this is air conditioning insufficient, but to separate or look little different, I wore, I don't know what is your situation, but at least I have Modi coat. But we need to understand. So the facade makes a lot of change. So somebody, one of the noted architect, he has worked on the different facades which are available in the world, and just I will go through it. See, these are all the forms. These are all the forms. So how that was developed, and why that was developed, where it was developed, with what situation it came. So it's very much available in your libraries and all. Please try to go through that old books where you will find all these things. Not on the every time ChatGPT or your Google will not help. It's very difficult. You go to your library. It's a beautiful library, centrally located. There are some books you will never find in at least Google as on date. So these are all different forms which can be made, and many of these structures are made in steel because of the ease. There are about 1001 by Francois. Now, friends, whether it's a tall building or small building or any type of building, for an architect, that's a model, isn't it? Once you create the model generation, as is shown some models with the framing, that's an internal, and it's like a bone structure. But we need to create some kind of an entire integrated system. So for me, in my research work, even it was an architectural form-based structural optimization. So here, every building which you see, that's a formation. It was extruded, it was twisted, it was in a different way it was produced. So these are the buildings, and they are the mathematical models. So once you create that, and then it goes to the structural engineer, then the structural design, and then the building services and all. It's an integrated team. So that starts from you. You need to know the entire domain, and then you will see mainly these structures are steel structures. I will go the little later about the structural system, but you can see these are possible only with the steel structures, isn't it? Rotors, hyperboloid, tardos, free rollers, orthoconoids, these are all mathematical models. Free shapers. Now, for architects, this is my small atrium, and it's a steel structure again. My house is a hybrid where my elevator is a steel structure. Even the what to say, skylights and other things are in a steel structures. So here, for architects, sun path is important, but for structural engineers, load path is important, isn't it? So if you understand the load, right from the slab to the bottom, that's your requirement. But for architect, something is different. It's orientation and all. And many of the people, they say, see, normally when I go to architects, I talk as engineer, and when I go to engineers, I talk as an architect. But here I'm little, both I'm taking, because front row is engineers and back they are architects. There is a difference, Mr. Reddy. They think that the common man, they think that what is the difference between the architect and the civil engineer or any such people, planner? But there is a difference. How it's, I will show you. What is 5 plus 5?
10.
What is 5 plus 5?
10.
Architect. No, instead 5 plus 5? 10. You are not an architect, but still 5 plus 5 is 10. You are an architect. 5 plus 5?
10.
5 plus 5?
10.
Wow. Now, sir, if I want to apply some kind, so this is totally white. Mr. Ramesh has gone to Delhi to take approval for applying the color on this building. Which color you would suggest if you were given a chance?
White. Light blue. White. Oh, maybe I haven't thought of it.
Just
Okay.
which color you like?
Maybe white.
White. Okay.
Blue.
Blue.
Gray. Gray.
Gray. Why the answers are different? The 5 plus 5 is engineering, and these colors, there's architecture. So how can you differentiate? Our thinking process is entirely different, isn't it? There is no one answer. That's why the Viva is tough. Engineering Viva, he can't fail me. But architecture Viva, they can torture us like anything. I don't know is there. Anyway, this is a. Now, steel as a substructure. It's not that we have to use only for the main structure, but substructure, the facades. The facades are the main where it becomes like a skin, isn't it? So those things are very much important. I'm not against concrete, and in fact, 95% of the buildings are made in RCC or concrete structures using, but still, I have a lot of flexibility to design my envelope to the required achievement of U values and R values, isn't it? See, I can have different facade, different kind of insulation system. So you must understand. You learn climatology, isn't it? But you go little next step and you try to understand the properties of insulation, the requirements of insulation, and the steel buildings gives us ease to create any kind of envelope. That's the beauty of that. Who is the architect? Jahadid, isn't it? Have you heard Jahadid, sir? No. Have you heard Jahadid? That's the irony of our fraternity. Sir, she is like Amitabh Bachchan or Aishwarya Rai for architects. But overall, taking a movie, we don't know the players. The same thing, if I ask who is the structural engineer of that, have you heard William Bakers? Who is William Bakers? Or Bill Bakers? You heard about Bill Bakers? No? Who is the structural engineer of Burj Khalifa? Who was the architect of Burj Khalifa? It's very difficult here. Who is the director of Bahubali? Second good na question anyway, I'm not, see, we need to understand where we are. This is the world which requires, who designed Eiffel Tower? Who designed the signature bridge? Who designed the signature bridge? Where it is, Who is from, anybody is from Hyderabad? Oh, you are in problem. Durgam Cheru Bridge.
డిజైన్ అంటే ఎల్ఎన్డి అనుకుంటున్నాను సార్ మోస్ట్లీ.
One actor had accident. Who was that? Just see the answers. But for us, the queen of the curve, because Zaha Hadid could become queen of the curve because of the steel structures, because of the steel, how she has not designed any of the element. Believe it or not, she has not even designed structurally any of the structure. But she had a team. She had because she passed away. Okay. Because of own reasons. So why she passed away? That's also a good thing. If you don't maintain the health, gone, isn't it? Why? That also you see. So here, for any construction, these people are responsible. But when it comes to basically steel structures, we need all these things. And here, the strength and durability, design flexibility, speed of construction, cost efficiency, sustainability, fire resistance, seismic performance, and low maintenance requirements. These are the requirements. If I am sitting here as an occupant, I am least bothered about what structural system it is, isn't it? If I am traveling from one place to another place, whether it's an electrical vehicle, whether it's a diesel vehicle, whether it's a petrol vehicle, whether it's a seven-seater, my ultimate goal is to reach from one place to another place safely, isn't it? So occupants we need to keep in mind, and the architects are related or in touch with the directly occupants, isn't it? Because you are doing to see, if I am a doctor and if somebody is a patient, for me we have direct relation, but he doesn't know who is the anesthetician, isn't it? Who is the medical equipment supplier, isn't it? But as a doctor, I need to know everything, and architect has to play a vital role to understand, because he's a leader in this particular field. Now here, right from the ancient, if something is different, naturally it's excited for eyes, isn't it? But at the same time, if you go for a Baba Amte Ashram or Sevagram, or if you go to Sabarmati, they are the real structures at that time when they had the sustainable one. So they are also good, these are also good. I'm not saying that these are only good. So today we are moving towards net zero. Even in fact, I talk much about the sustainability. I have designed one small building for my family. My entire family is of architects. So it's about 7,000 square feet triplex, which is a net zero building. Because I should experience it, isn't it? And if I'm having a 140 kg and I say that you should have less weight, so it's difficult. I have to experience, I have to maintain myself, and then I can say, isn't it? So my building, almost all, they are nearing to net zero, so possibly. So here, friends, we need to understand one thing as an architect, whether it's a steel building, whether it's a composite building, the human comfort in the built environment is very important. And that, if you take a curve like this, it's like a curve, S-curve. Now S-curve is in nature. Okay. Now S-curve is nature. Morning we have some temperature, afternoon we have some temperature, humidity levels are different. But by the way of the design, passive design, you make this wave near to the comfort zone. So we need to understand what is comfort zone. So 100% we can't achieve with the passive techniques, isn't it? We need some kind of active systems like fan or air conditioners or coolers or exhaust fans to have a better comfort inside. So I feel minimum of active, maximum of passive can be done with the good design of an architect, isn't it? So that is your role, which hardly engineer will understand. He can understand what we need. He can give the better system. But again, I am saying I am resembling with my profession as a doctor. He can create the medical equipments. He can create the pharma tablets. But where to give, when to give, how much to give is doctor's rule. Doctor's work. So there we need to have coordination. So here the comfortable things, how that comes, we need to understand. So good that you are staying in having education in such a beautiful building where you have a lot of daylight and other things, less of active systems. But here, features of envelope, fenestration, orientation, shape and shading devices, and daylighting. If you have gone to SRM University, here in Amravati, the upper, that shading device, that was added later and at the design stage. But it gave about 22% of the energy efficiency inside. And that was possible only due to the steel structures. So even though I have a base as a concrete structure, but I can have canopies, I can have shading devices, I can have some kind of a skylights in steel, which is a beneficial thing to use it. So here HVAC, artificial illuminations there. HVAC is very important, building services are very important, that may be electrical, mechanical, plumbing, or any vertical transportation or any other building services, we need to understand that. So here, whether steel is good or concrete, the whole day is there. I will leave it to the experts. So naturally, that depends. Organic food is important or inorganic food is important? That depends. इडली अच्छा है या इडली के बाजू में बर्गर अच्छा है? So रोज अगर बर्गर खाओगे प्रॉब्लम है, कभी कभी इडली खाओगे तो भी प्रॉब्लम है. So we need to understand. We have come to 21st, even 21st century. Still, in my college days, sir, I attended INSDAC about 25 years back. The same thing was told. Steel is good, steel is good. But still, we could achieve 5%. But I think with the collective things, and the minds of the architecture, it can go fast because architect is a specifier, isn't it? Try to understand which are more sustainable. These are all things I will leave it to next speakers. So metal technology, it's not, as ma'am said, metal, any metal. It's not just steel or stainless steel or copper, but metal industry or metal elements are very well, it can be planned. You can see the structure, if you see the standard pattern of the concrete structural system and steel structural system. So many of the tall buildings in the world, they are in the steel. You can go with the good structural system, more taller than the concrete to some extent. So we need to understand how that, and if you understand why, that's good enough. You are not going to design any steel structure or concrete structure. You should know the behavior, isn't it? Once you know the behavior, then material comes. You know that steel is in good intention and concrete is in compression. So our structural behavior, it should be known to you, and so that they can supplement that particular thing to you. Naturally, the steel structure is the fastest, isn't it? Because you can do it very quickly, because some things can be at factory and some things can be at site. So we can combine it, and the firms or manufacturers, which they are collaborating everything, because they are the real collaborators. In fact, this guy has a very tough time always to coordinate architect, to coordinate structural engineer, to coordinate with the building services people, right from the foundation to the finishing. So they have the toughest time, and naturally he will be presenting after some time in his own way. So here you can have a hybrid structures. And if you go to any time into Hyderabad, Ring Road, you will find some structures which are very, and even Mr. Reddy may be designing few. So here we need to understand the less material is the better, isn't it? The steel requirement is less compared to the concrete. Naturally, that will be sustainable. So integrated design is very much important. We have to come together to make this happen. Now, industry growth and acceptance. So this all this, what are these things? It's not, see, architecture is not only for the buildings, which we occupy for some functions, but there are so many structures or buildings where architect can go. It's not only within the city or within some scope. So you have a lot of scope. So try to explore in the agriculture, in aviation, then in government buildings, right from the secretariat building to institutional buildings, and then healthcare. So where you can opt different types of structural systems. The recreational, yes, today we are having a highest and a longest span, where the deflection control will be controlled by the structural engineer, but we need to have column-free space. So we need to understand how the creations, and these things will be a part of your thesis in the project work, isn't it? So recreational, then restaurants and beverages, and then auto dealers. Today we have like Kia Motors or some, they're all steel structures. It's a very easily you can go for the long span structures, multi-story car parking complex or anything. That's a very important. Educational structures, you can have better utility of steel. The retail, yes, you can have hypermarkets, isn't it? Will it possible to go for RCC for those structures? No. So here you are planning a space. Leave about whether the steel or so, but keep these in mind and you design it or you plan it. So architect job is to create some kind of a built environment which suits the function. The structural engineers and other people, they will support you, and then you can go for that. You should know who is who and what is what. So offices, and then religious structures, and then manufacturing and warehouses. Today logistics is very important. Within seconds you need it. 10 minute के अंदर आपको आना चाहिए. So tomorrow the world is for hubs, logistic hubs. So logistic hubs, where to put, when to put, what is the, that will create lot of networking. So here architect's role is very important. Like he said about data centers, we need to have the storage of the things and when to get. Data center, you are putting it, getting it virtually. But here, ऐसा नहीं होगा ना, virtually थोड़ी कहोगे आप. So Amazon and other people, within no time they are coming in, isn't it? So design responsibilities, the codal things, see Bureau of Energy Efficiency is coming with so many things. You try to understand what those things are. And these are the codes available on the web and other things. You can download it. You try to apply in your buildings. So climate zones you need to understand, like earthquake, we need to understand the seismic zones. For our built environment, we need to know climate zone. Here the climate is different, Hyderabad the climate is different. The public, so for example, this particular thing where the sky conditions, temperature and dew points, and the heating and cooling degree days, I have compared some of the case studies where we have different structural systems, but they're mainly steel structures with different facades. So here a lot of things go to the atriums, what is the stack effect, what is the Venturi effect, those things we need to understand, and accordingly you can do it. So here the apartment building where you can have some kind of a fans, some kind of a, see I have wind turbines on the type which takes the heat outside due to the stack effect, and I'm generating small way the wind turbine electricity, the solar, so renewable, because to make it net zero, we need to introduce all these things, and this particular thing can be done very easily in the steel structure rather than other things. So cutting is cladding solutions are there, and today, other than residential building, you see lot of types of structural glazings are coming. So there we need to understand what material, what metal it can be used it. So for example, the energy efficient building envelopes, we have some kind of a calculations, but I won't go into the technical details. I can share those details with you through your professors, and you can go through that and make your built environment more sustainable. Heat transmission, heat convention, what are those things we need to understand. You have the, for example, I can't go with the same costume in Kashmir and Rajasthan and Chennai, isn't it? We need to change. If I go with this in Rajasthan, it's very difficult. If I go with this even to Kashmir, then it's again difficult. So we need to understand what is my envelope, and then this R value and U value is very important. Normally in our conditions, you should have very less U value and very good R values. So those things, resistance and all, we need to understand. And they are very clearly given below the product, behind the product, what is the U value of that particular product, what is K value of that particular product, how those things can be done. Even glass when you are taking, every specification is written, but we need to understand that. And as a specifier, again I am telling you, you are specifying a product. If I am a doctor, I will specify some kind of a medicine based on MG and other things. I know everything. But as an architect, to what extent you are knowing the product specifications, and please educate the architects and structural engineers and specifiers about the technical things so that they can be more bold to use those things. And that is also your job. It's not just availability rate and ease of work. Friends, I'm going nearer to my presentation closing, but this particular thing, another 5-6 slides, inspired by architecture. See, sometimes what happens, if I see Bahubali, I will get inspired, no? I mean, I can't climb the, elephant and all, but virtually, but anyway, some things, some techniques. There are some techniques are there in Bahubali, which we saw in the childhood, Tom and Jerry, the calculations and all, how that bow goes and all. So here, if I'm an architect sitting there, so I will be inspiring some other people, like those who are in the front and outside. So our architecture also influences others. How that influences? Like this. Buildings influence that particular dress designer to come up with such particular design. They are very close. As I said, building and human body is not so separate. And here, Rosie, who got the inspiration from that particular geometry of the structure. Frank Gehry, Frank Gehry, in fact, those who are not aware of Frank Gehry, architects they know. Can you give me some piece of paper, please? Rough paper. And notes, जो notes लिखा नहीं उस पर वो वाला. Now, for example, Mr. Reddy, I will make you a client of mine if I am Frank Gehry, and you are such a typical personality. And if you want to come to me and want your home to be designed, I will discuss with him. You know what Frank Gehry does? But he's a very good guy. Now this guy so, and for example sake I'm doing like a rowdy shooter and all of things. Your personality is not there, but still. So he comes to me and I know that he's going to be a different guy. So he's a plain paper and so anyway, the thing is, Frank Gehry does all the things, but the next thing is engineer's challenge. They have a lot of challenge to design it. Where the elevator will be, whether the staircase will be, how the facade will be. But you can see his YouTube channel where he explains this thing, in a different way. I made a story of that. Now anyway, Zaha Hadid, one of the best architect in the world, she had whatnot, and she had integrated everybody in the domain together to have this happen. Now we are taking example, isn't it? But that also influenced somebody to come up this dress. Now this particular thing, Japanese film, and then here I think which is dress and which is landscape, I am not able to identify. But the nature, landscape architect also can influence. Now in our days, sir, your days and my days, we had jean pants with bottom we used to have zip because वो फटना नहीं चाहिए बोल के. But today, I am not against this or I am not in favor of this, but somebody have designed this, but with what influence? What influenced him to come up with this particular thing? I tried to research. I thought he was living in front of me that inspired him to come up with this. No, it's not like that. It's only my view. Anyway, friends, building envelope or building structural system or any built environment in that for any function, I feel I need to have some kind of a support system, some kind of an envelope or slabs. If I have a long span, the deflection problem. If I have a tall building, the sway problem. If I have my own requirement and go to a structural engineer, don't say that you use this or that. Adopt steel because that's the future. Because you have a lot of ease. We don't know that. एक ही बात है sir, and from architects fraternity I am telling you, what they teach us, normally that scares us. The people, those who are, the irony of, openly I can say this, the irony of this particular architectural education is building services, architect can teach. Climatology, architect can teach. All the subject, architects. But for structural, civil engineers are teaching to the architects. Why an architect teaches the same subject? Because that is also that limited only. You are not going to design anything. So I feel we need to understand the mindset of the people, and then if they specify steel, see, occupant is not going to have any say no to it. because they should understand the benefits of the steel, because that is in par with the concrete. In fact, more than concrete. So I think we need to understand the requirements of the overall built environment and work it, and let us collectively shape a better world with better buildings, steel buildings. Thank you. But before I leave, uh, last word. Uh, See, we try to be almost high performing, isn't it? Perfect. So to end, just to make the things light, because he had a very, very big dose, heavy dose. After that, I don't know about me, but anyway, how many are married here? I mean, few people are married here. अरे सिगबड़ते बाबू ये हाथ नहीं कर रहा, यहाँ कुछ नहीं होने वाला है. Anyway, sir, are you perfect?
Never. No.
No. Are you perfect?
No.
Are you perfect?
No.
Are you perfect?
No.
I am also not, but still, students, are you perfect?
No, sir.
अरे यार, कोई भी perfect नहीं है. Are you perfect?
No.
No.
Perfect in what? The other day, I was in Delhi and I started with one end. He said, I'm perfect. And I thought, I got a wrong answer. So he said, sir, as a human being, I'm not perfect, but as a photographer, I'm perfect. If I say I'm not perfect in photography, they will not give me the bill. So he was a photographer of that particular event. So here, friends, once, and I will take another 1 minute. Once the team of Sri Harsha Consultants or the office wanted some kind of a, to employ one good structural engineer. Here I will not say architect, structural engineer. And when you give advertisement, then about 500 people they apply. Now naturally 500 people, but one person has to be selected. Then there should be some kind of basis, isn't it? Then there will be a written test. Naturally, ma'am has given some assignment today also. For those who submit some kind of a one page, they will get some cash prize. Anyway, so then out of 500, when you were test, the screening, only about 10 people they left. Okay. Out of 10, I cut short. There are different stages, but the 10 people they left for one post. Then naturally, the sequence will be, the selection will be based on the interview. Okay. So Mr. Harsha will, Reddy will be sitting. Mr. Gopal will be also there. So team of the panel. And the rule is you have to come from this end and go that end. No discussions. Only face the interview and go home. If you get it, you have to come. Otherwise, there is no communication. That was the rule. So then again, Sunil, somewhere sitting here. So Sunil is also in that particular interview. Then he comes first. And Mr. Reddy asks, what is 6 into 6? Just listen carefully. 6 into 6. So naturally, चाहे वो simple question हो कैसा भी हो, the question is question. So he takes little time. Mr. Reddy asks, you want calculator to calculate it? No, sir. Take your time. Yes, sir. So 6 into 6, 6 into 6, he says 30. Then he goes home. When he goes home, and then he calculates, कितना है? 6 into 6, 36. Arey, I told 30. Then gone. So fine, third day, his sister calls and says, there is a letter from Sri Harsha Consultants. Can I open it? He says, don't open it. So he comes home, goes into the room, slowly he's opened it. Here it's written that you are selected, you join from Friday. So naturally when he comes out, the family member said, what happened? I got selected. But why you are not laughing? You should be very happy, no? तो नहीं वो कुछ problem है. So anyway, the Friday he goes to the office and then he goes and he will be searching for Mr. Reddy. Then the colleague says, why you are searching whom? The person who is MD and who interviewed me. Yeah. So then okay नहीं वो आज नहीं आएंगे, वो तो साइट पे गए हैं, वो क्या बोलते हैं हाईटेक सिटी का 4th phase को देखने गए हैं. So then okay. Then Saturday in the corridor, when this Sunil faces Mr. Reddy on the corridor, he will be standing like this. Sir, good afternoon. Mr. Reddy says, Sunil, welcome to our firm. Very happy. All the best. He says, no, sir, there is some problem. Please tell me, sir, why you selected me. बोला क्या यार तू तो सिलेक्ट हो गया क्यों टेंशन ले रहा है तो नो 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 मुझे सर प्लीज टेल मी 2 दिन से मैंने ना खाया हुआ है ना मुझे नींद आ रही है सो प्लीज सर प्लीज टेल मी बोला नो टेक इट इजी नो सर वी वांट देन ही सेज मिस्टर सुनील यू वर नियरर टू द आंसर गॉट इट so 6 into 6 is 36 but my answers were 30 so among others I was near to the answer so we are not perfect in the life but we need to be nearer to the answer I don't know what is my score today but please I, I may be about 20-25 so I will try to become 36 with the incoming future. So with this, I would like to end my presentation. So I will be here up to the evening. If anybody has any problem about the planning, designing, execution, operation, and maintenance, which are the 5 elements like Mahapanchabhutas, which should be learned and practiced by an architect with all these team members, whether it's the steel or concrete or wood, I think we need to be together. Thanks a lot.
Thank you, Dr. Anshuri, sir, for your valuable insights. Next, we have Mr. Shiladitya Chanda, sir, the Assistant General Manager, Civil and Structural at Instack, with over 21 years of experience in the steel sector. Mr. Chanda has made significant contributions to engineering, project management, and strategic planning. His work involves promoting the use of steel in construction through collaboration with major steel producers, architects, and industry bodies. He has also published several technical guidebooks and led numerous seminars. Please join me in welcoming Mr. Shiladitya Chanda.
Thank you. Thank you, Mr. Reddy and Mr. Anchuri, for setting the standard so high. So it is incumbent on me to, keep the pace. Anyway, just to start with, when we were in younger days, when I joined in Instack, then I used to hear a lot of lectures on, say, finance for non-finance guys. And say, since I was in Instack, so metallurgist for non-metallurgist. So today, you are going to, just for next 30 minutes, you are going to listen out a lecture like that, structural for non-structural persons, okay? So you have to bear me out for, say, next 30 minutes. I will try to be as crisp as possible because I know, because my background is structural engineering background and you are mostly architectural. So I may bore you a lot, but please try to bear with me so that today my particular topic is pre-engineered buildings. So I will try to limit my presentation to this pre-engineered building and will try to introduce the subject very briefly to you because there is another expert sitting over here who will just take over after the lunch. He is Mr. Narendra, representing Interarc Building Products, a leader in this particular industry. So I'm sure he will be showing a lot of case studies and all. Those will be even more interesting to you. Okay? And being the last speaker before lunch, and you must be hungry, so I would limit myself for a limited period of time. And being the last speaker, there are a lot of disadvantages, as you know. And one of them is whatever I have thought of sharing with you, much has been already shared by these two experts. So there is almost nothing for me to share with you. Okay. Anyway, so this is what we normally called a pre-engineered building. Okay. So why it is pre-engineered? Because we say that everything is predetermined beforehand. And why it is predetermined, why it is called pre-engineered, I will come to that later on. I would not like to spend much on this because advantages of pre-engineered building, because as I believe a lot of advantages you already know about this, and Mr. Narendra will deal with it in a much deeper sense. So you can see faster construction, high strength to weight ratio, it's all known. Expandability. So I'd like to draw your kind attention to the last one, that is pre-engineered buildings. As I go along, you will see, I mean, it has improvised the traditional design in number of ways. So in one word, you can always say that pre-engineered buildings has standardized the quality of construction. But I would like to go a little above, one step ahead. It has not only standardized the quality of construction, it has also standardized the space. Because pre-engineered building per se, whatever the photo I have shown you, you must have realized that I must be talking about a shade, industrial shade, a kind of thing. But nowadays, it's no longer valid. Pre-engineered building, this particular concept can be applied to anywhere, not only in typical structural shed or warehouse. So that is why you can always say it is basically an improvisation or a standardization of space as well, not only quality. So these are a few of application areas you must have already know of this, and I'm sure the next speaker will, deal with it in a much better way. So I would like to deal with this kind of things, why it is called pre-engineered building, what is the engineering behind this, and I will also like to touch upon some construction issues. What are the typical bad detailing that will lead to failures and all. So as I believe you are architect, and after say few years you will be start practicing on your own, and you will must be dealing with a lot of such structures. So you must be aware of such typical errors that are frequently happening in the construction sites. So here it is, frame optimization. So being an architect, you must be introduced to this particular aspect, okay? The bending moment diagram of a typical frame. So here on the top, you can see that is a typical bending moment diagram for a frame under dead load, live load condition, okay? If we consider the base as pinned, right? So if that is so, why do we need a straight column over there? Because you can see at the base there is bending moment is 0. Okay, so you don't need to provide a depth of say 500 depth column over there. So what we'll do is we'll do like this. Even this is a dead load wind load case. So what we'll do is we will try to provide this thing, the profile of the shed like this, by varying the wave depth. You are aware what is flange, what is wave, okay? So if I put a minimum wave at the bottom, at a maximum at eave, okay? So that is my pre-engineered building because I am optimizing. That is how I am optimizing. So this is how we can call this as pre-engineered building. And this is not alone. There are engineering improvisation in number of ways that I will come to later on. This is only the frame, okay? There are other aspects as well where we have improvised the design. So this is a typical form of a pre-engineered building. You can see light is there, pointer, this one. So this is we call rigid frame. You can see at the base there is minimum section. This is we call if, there is maximum section. Here this is reach. You can see there is a varying depth. These we called purlins. These are bracings and all. So I will come to all of this later on, but I will just touch upon those. I will not go deep into that because all those things are engineering and structural part. I will only try to touch upon all those things that you might be interested in. So these are typical spans for which you may find pre-engineered buildings are economical. And I mean, I will share with this, so you don't need to write all those things. You can always refer to this particular PPT and decide on your own. So here I am trying to introduce what are the main components of pre-engineered building. Pre-engineered building is primarily composed of some rigid frames. That is the main frame I talked about. Then rigid frames are mostly it is I section, but not the conventional one. The I section built up with a flange, two flanges and one web. The conventional one is the roll section that are commonly available in the market. But that is a straight section, you can't alter. Well, I'm saying you can't alter, it's not exactly true. You can alter, that is we called, say there is one concept of castellated beam. Therein you can definitely alter, but I'm not bringing that particular aspect over here. Anyway, but the conventional one, basically you can't alter, but here you can alter. Okay, so that is what it is pre-engineered. Then the end wall framing, there are two types. Anyway, you might skip that for the time being. Then purlins and guards, here there is one innovation. The purlins, whatever you might have taught in your class, the purlins are normally you must have taught that the channel sections can be used as purlin, or the circular or the rectangular sections can be used as purlin. Here we are introducing one Z section. Z section made up of steel thin sheets. Okay, so these are called purlins, and here while I talk about this Z section, you will see how the design can be improvised with this Z section also later on. So these are common bracings, then the fasteners and all, these are there in every structure, okay? But here, let me tell you one thing. While we say pre-engineered buildings, there is a typicality. The pre-engineered concept has been understood by some, I must say, but misunderstood by many. Because just a few days back, someone came to our office and they said that they have received one quotation for pre-engineered building wherein the vendor has said, sir, there is two pricing. One is as per IS code and another is not as per IS code. So you can imagine why I say this particular concept has been misunderstood by many. Because in the name of pre-engineered building, everything is happening around the country. People are providing 4 mm sheet as main load-bearing member, 4 mm plate, 5 mm plate, and a lot of the basic structural concepts are not being followed also. So it is incumbent on your part to check those. I understand you are architect, but you are also the guardian of your project, the custodian. So you need to aware of such kind of malpractices, as I would like to say. Okay. Anyway, let's move on. So these are some typical arrangement of cranes. There can be multiple arrangements of cranes. So these are there. It can be gantry, underhang, zip. It can be many actually. So what are the design philosophies? Okay. So design philosophies, obviously you are aware that there is IS 800, that is our mother code. okay, for hot roll section. For cold form section, there is IS 801. But kindly note, this IS 801 is a very old code. Presently, we are in the form of updating one, and very shortly, the new code will come. And kindly note the last one. It's a very recent code, IS 18186. That is basically, are you aware of by any chance 13920? 13920 is a code which deals with RC detailing in earthquake zones. Okay, so this particular code 18186 is a recent development, and it is actually the steel detailing in earthquake zones. But the good news is this code would also not be there for after say few years, because there is an understanding among the code committees that all the earthquake committees and the steel and RCC committees will work together, and they will come up with a second version of IS 13920, and this particular code will be withdrawn. Because as an user, we would not like to consult too many codes. Then the whole purpose will be defeated. So that is why this particular code will be withdrawn after a few days. So these you all know, I believe, loads. So I don't want to go into detail of this. Deflection limits, again, this is for your reference. You can note, else, there is no point. Because, I think you are aware of the basic design consideration, that is the strength and the serviceability. So this particular sheet comes under the serviceability concept. So this is one thing that I would like to draw your attention. As I said, in pre-engineered buildings, the base can be pinned. Okay. Now tell me, is it really possible to have the base pinned in true sense? What does the pin mean? Pin means there is no moment. Okay. The moment will be released. Is it really possible? Practically, if you see, practically it's not possible. Whatever the distance of the two bolts over here, so some moments will be there anyway. So for all practical purpose, we can assume that there is no moment, so and we go on design. But this is just for your information. Practically, there shouldn't be a case where at the base you will get zero moment. So these are typical connections. Now you see this one. As a architectural students, you must be aware of some bending moments and all. Okay. So just consider a typical continuous beam. Are you aware of that? This is a typical continuous beam. So what is the bending moment diagram? Here you can see, here in the span, bending moment value would be WL by 24. And in the support it is WL by 12. So basically here the bending moment diagram, bending moment value would be more than this span. So since at the support bending moment will be more, how do we really engineer that? Now you see, as I said, Z sections are used as purlins. You can see here what we do, we overlap these two sections. So this is a zone of overlap. So basically, at the support, you have two sections. Okay. So that is how you overcome the greater moment of bending moment over there, and you are providing basically two sections. Okay. So that is again an improvisation of pre-engineered buildings. So these are normal purlins and guards overlaps. I will not like to go into detail into this. This is one. Just see. You will be dealing with a lot of structures later on, 3 years, 4 years down the line. Fine. Now you see, here is a column. It is actually taken from a completed project. And there is some gap over there. They have not bothered to plug those gaps. and it is actually a completed structure. Now you see how will the bolts will act. If that is the level of finishing, you can't, whatever you are assuming, you are designing, you are constructing, all those things will go into vain if this is the level of construction. Okay? This is storage. Now you come to this. Are you, by any chance, can anyone tell what is this photograph? Just any idea? Bracing, right? Yes. So bracing, whatever you have learned, you are mostly from first year or second year? Which year you are from? Huh? I didn't get. Okay. So you are more or less aware that the bracings, in whatever form it might be, should be concentric. This is the center of the column. This is a column. This is the center of the column. Okay. The bracings in whatever form should be aligned with this line. Now you say whatever bracing you have, it is actually coming down to somewhere like this, not at this point. So, are the bracing performing its duties? No, because it is not coming over here. So is this bracing also. This bracing, whatever its center line is not coming down over here. It is meeting somewhere behind the column. So if that is the level of construction, so you can't be assured of your structure. Whatever structure you are designing, you can never be assured that my structure, whatever I have designed, will act in the same way that I have conceptualized. No, that is not going to happen. Okay? Anyway, these are, I can skip these, again I can skip. So here I will like to stop on this particular pre-engineered building business. So I would like to end my presentation with some general things. So that day when I was meeting your director, so he was saying something about how the load will be transferred to the bottom. So if there can be one slide. So I have tried to, finalize one. Here, there is a typical structural set. Forget about pre-engineered building. It's a typical structural shed. Any shed for load. Now, how the load will be transferred? Vertical loads, I am not dealing with because I know you already know that thing. Okay. Now, suppose, so there is a horizontal load on the structure. From wind it can come. So how it will be transferred to the, what is my purpose? Being a structural engineer or an architect, what is my purpose? My purpose is to transfer, because sir said, as an architect, your intention is to sun path, and from the structural engineer's point of view, our intention is to traverse the load path. Okay? So how the load will be transferred? So this is how the load will be transferred to the foundation. Okay? While my force is from this direction. Okay? Now, this is okay. Now, when my load will be from this direction, what will happen? Who will transfer the load to the foundation? This particular load. Now, you just try to imagine the moment there is a load from this way, and this is a very elementary thing. The next thing is, this particular bracings are there, so this particular triangle will come into action. And while you deal with architecture and structural steel, you know triangle is everything. The more triangle you have in your load path, you are always safe, because triangle is the best way to transfer load, right? So this particular triangle will come into picture. So this load will be divided into here and here as tension, here as compression, and again from here to this triangle and then to foundation. Simple. So that is the importance of providing adequate bracing in the longer direction. Okay. And as I said, something in very general, we were talking about pre-engineered building, from pre-engineered buildings to steel buildings. So steel buildings, we are dealing with steel. So steel is basically as someone said a few days back, steel is basically a truly B2B material. What is a B2B? What do you understand about B2B material? B2B normal parlance, it is business to business. And this particular case, B2B is blade to bridge. As ma'am said in the morning, steel is a perfect material from pressure cooker to PSLV. So for buildings also, we always say for buildings, you need the strength and serviceability, you are aware. But now another thing is coming into picture slowly, and all the codes, whatever codes today we are making, all the codes are talking about this, the center one, durability, and then the ductility or the restorability. What does this restorability? Restorability is a combination of this robustness and integrity. And I don't have to tell you what is the robustness. You just look at your own building. It's a huge building, but do you feel from a distance, do you ever felt this particular building is slick? No. It is a huge cantilever, but at the same time, this building looks from a distance, it's a very robust thing, isn't it? Your building? It is so much of cantilever, but you look at this building from a distance, you will always feel we are in a safe building. It's so robust. So steel building actually plays a great role in this robustness. So robustness and integrity combined together, we can call this as restorability. And how this, if I need to break down this further, then come to this. So steel plays a great role in ductility. And ductility per se, it's not about material. Material is the left-hand side, you can see. That is linear. Steel obviously is linear, steel's ductility. But there are ductility in other four areas also. These are sections, then material itself, connections, and the building as a whole. Okay? And where we consider the whole building, it's not about linear. It is basically a combination of linear behavior and non-linear behavior. Nowadays, you must be having, heard about the concept that is strong column, weak beam concept. So those things are to be come into picture. Okay. And lastly, it is myth versus fact. Why I have included this slide? This particular slide, because do you know about this thing, safety factors, factor of safety? You heard of this thing, no? Factor of safety while we design. What is this for? Factor of safety. A few days back, someone told me, because from Instag we used to, vet or approve a lot of design structure. Okay. Someone came and they said one particular building was designed with Fe 350 grade steel, and by mistake the supplier has supplied grade of steel 250 and the whole building is made. Now they came to me and said, you please approve, because there was factor of safety taken. So although the building was designed with 350 and constructed with 250, since the factor of safety was taken, you please approve. Now my point was, what was this factor of safety? Was this for calculation error, or your material error, or this bad construction, or for the bad material? The answer is no, not at all. Factor of safety is not used for any of these. It's not for key one building you have designed with 250 and constructed with 250, although the building was originally designed with 250. No. Factor of safety is for completely different thing. These are possible overloading and possible change of strength and dimensions. Okay? So please keep those things in mind that we are, as a structural engineer, we are entitled to do error. Everyone does that. But factor of safety will not going to save me. If I do some mistake, then I need to correct those before it is constructed. But no, don't fall back on the factor of safety, the great thing, and you can say, ki, I am safe. No. And last but not the least, you are basically very junior to me, so, but you are a blessed generation, I would like to say, because as I say something, you can always, use your mobile and check the veracity of my claim. So don't don't depend too many on the tools. Depend on technology, but understand the technology. Go deep into it. Do not overuse the tools. Tools will take you away from the main technology, the main concept. Okay? Thank you very much for your attention.
Sir, in your presentation, at the foundation level, because due to the wind load, there will be some lateral load in the bottom, in the pre-engineered building. Suppose there is a situation, the pre-engineered building is planned above the RCC building, after fourth floor, because there's a similar situation in our campus. We are constructing a sports complex, and we want to, above the fourth floor, we want to do badminton courts. Then earlier it was planned for our entire structure as RCC. Now, due to certain reasons, then we want to go for above the fourth floor, pre-engineered building, above the fourth floor. So since there will be a lateral load, you said on the foundation, but this RCC building was not designed for that lateral load. Because we are going to erect a pre-engineered building above fourth floor. So that means when it is not designed for the lateral load, the columns, then do we need to check for the lateral load effect on the columns?
Sir, 100% too. Hello?
Thank you, sir.
Yes, it is. If the original structure was not designed for the fifth floor.
Yeah, there will be fifth floor because we are planning badminton courts.
It might happen that the original structure was designed for a fifth floor, but it was constructed up to fourth floor, and later on another floor was added, but not in RCC with steel.
Yes, correct.
Then that is okay, because the fifth floor was anyway there in the design concept stage, and lateral load was anyway considered for the in case of wind load. But if it was not, it was designed with 4 floors only, and later on we are trying to add another floor over there, then it must be checked with all the loads, not only the lateral loads. It should be checked with all the loads that your newly proposed structure will be giving.
Thank you, sir. Thank you very much.
Thank you, Mr. Chanda, for the comprehensive presentation. We will now break for lunch. Please be back by 2:10 for a special presentation by our sponsor, Interact Building Products Limited. The students who are hostelites will have to go to the mess, and for our guests, lunch is available in front of the cafeteria. Thank you.
Hello, 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 hello.
essay, one-page essay on the, in 4 projects you have done, right? We have presented 4 projects. Either way, you need not write 4 projects description, at least one project, what you understood, just give a description so that we'll evaluate quickly, and 2000 rupees is the cash prize. Grab that opportunity. And also, what you people should see, that models, I have brought it for you people to see and enjoy the concept of it. That especially that data center, go there, observe how it has been done, take some photographs, you can utilize that models. And also high-tech's hall number 4, also you can take some photographs and observe that what exactly has been told, and whether you have any doubts are there, just we can interact also, no problem. But you should have that kind of a enthusiasm to look at from your angle how it can be designed. Otherwise, the purpose of coming here with the props of no use. Just show some interest on the props. Go there and see. After 1 lecture or 2 lectures, whenever there is a break, just go and observe that. Thank you.
Thank you, sir. Welcome back, everyone. I hope you enjoyed the lunch. Now we have a special presentation by our platinum sponsor, Interarc Building Products Limited. Please join me in welcoming their representative to the stage.
Hello. Thank you, ma'am. A very good afternoon to all of you. It's indeed a pleasure and an honor to be here addressing this august audience of engineers, architects, structural engineers, and of course the student fraternity. Thank you very much for giving me this opportunity for making a very small presentation about pre-engineered buildings, their role in making sustainable buildings, and particularly the role of Interarc in this entire gamut of sustainable buildings. Okay, okay. Yeah, so to start with, I think I'll come on this stage. See everyone, I think, better from this position. Yeah, to start with, we all know that building materials which were traditionally used were like bamboo, wood, or straw, mud. I mean, that was in the maybe the 19th century. 20th century, we saw concrete coming into picture. Like in 1914, the first concrete building was made by Le Corbusier. Concrete has its own disadvantages, like I mean, it consumes almost 10% of the global water, industrial water. It accounts to almost 4 to 8% of the carbon dioxide emissions worldwide. And it traps a lot of gases and heat within a building. Concrete dust also contributes to many respiratory diseases. So although it's a durable and a strong material, in the long run, concrete will not be a sustainable material for construction. Steel, on the other hand, is a recyclable. As a matter of fact, it's a multi-cycled product. Like a lot of our eminent speakers today morning, they have emphasized on that. That steel is a material which can be not only recycled once, but recycled again and again and again. I mean, it's a cradle-to-cradle material, literally. This is just an agenda what we will be covering today. Really, the role of pre-engineered buildings in the sustainable, producing sustainable future, and particularly the role of Intrac, what we are playing in the entire process. Now, what is a pre-engineered building? Mr. Shiladitya has really elaborated a lot on pre-engineered buildings and especially the technical aspects of pre-engineered buildings. So I would really not go into that. As a matter of fact, I haven't really gone into the technical aspects, thankfully. Otherwise, you all would have been really bored, especially after a good lunch. So in short, a pre-engineered building is something like a mechano set, you know. So you make the buildings, columns, the beams, the rafters in a plant, which is known as it's manufactured off-site, and then it's shipped to the site where it is just assembled like a mechano set using bolts and nuts and washers. You know? So what are the advantages? One is steel is of course a very strong material. So it has the strength, the resilience to withstand all the forces of nature like wind, earthquake, the gravity loads, etc. They are cost effective. Why? Because they are almost 25 to 30% lesser in cost because they are lesser in tonnage compared to your hot roll buildings. Speed of construction is very high because, as I said, it's like a mechano set. So you just bring in the materials, you assemble it at site, and the speed of construction reduces drastically. So these are some of the advantages of pre-engineered building, and it's a very growing industry and growing at a rate of almost 10% every annum. What are the codes that we follow in pre-engineered building? They are same as any other steel building, so they are nothing, we don't use any special codes as such for pre-engineered buildings. We follow your AIC codes, that is the American codes, or we follow our Indian code, that is IS 800-2007. Wind load analysis as per IS 875, or if it's American code, we use ASC 07 for the wind load analysis. Seismic design is always done only as per IS code, that is IS 1893, or as Mr. Shiladitya said, now the latest code, to be honest with you. Cold form designs have been done as per IS 801, 1975. We do 2D and 3D structural analysis using either StatPro, which is a very common software, which I'm suppose you all people must be knowing about. Or we also use what is known as a metal building software, MBS. That's an American software, basically for design of pre-engineered buildings. Now this is a slide which I'm sure you all people have seen it in the first session. Mr. Shiladitya has, elaborated and discussed about this in very detail, so I would really not go into it again. The reason why pre-engineered buildings are less in tonnage as compared to a hot roll building, because the shape is followed as per the shape of the bending moment diagram. Steel is a recyclable material. We all know that it can be recycled again and again. And in pre-engineered buildings, we use roofing and claddings which have got an SRI value, that is a solar reflective index value of at least 78 for low slope roofs, or 29 for high slope roofs. That is as per the IGBC guidelines which we follow. We go for modular construction, which is very easy in doing it in steel buildings. And steel is a very resilient material, which again we have discussed a lot in detail today morning. So I would not really go into it again. Pre-engineered buildings incorporate a lot of green roofing systems. In what sense? Like most of the buildings will have what are known as ridge vents or roof monitors at the ridges. And we have levers at the bottom, normally on the walls all around the building. So the cool air will enter through the levers, push the hot air up, and it will go out through the ridge vents or the roof monitors. So thus you have a complete air circulation taking place. So that is known as an air change, what happens in every building. So, normally we have guidelines, like we have IS codes which specify warehouses should have an air change of say 6 to 8. or those with mill buildings, they should have a air circulation of almost 10 to 12 air changes every hour, you know. So all that is being taken care of by these ridge vents and roof monitors, which are given. Natural lighting, we give what are known as skylights or wall lights on the walls or skylights on the roofs, generally 3 to 5% of the roof area. So that helps in giving natural lighting within the building. It reduces your load on electricity. Artificial lighting load has been reduced due to that. Then stormwater drainage is what is normally taken care of in all the pre-engineered buildings nowadays. So your accumulation, your purification of your rainwater drainage, and then recycling it again for use. And last but not the least, most of the pre-engineered buildings are insulated ones. So your roof and walls have got insulation in the form of either rock wool insulation or what they are called as your glass wool insulations or XLP or bubble insulations. So which insulate your interiors and help in maintaining a good ambient temperature within the buildings. So again, it reduces your need for heating or cooling of the interiors and the comfort of the interior people inside the buildings. Solar panels are nowadays always used in most of the PV buildings. So we always design all solar panel, all roofs for solar panel loads. About 20 to 25 kg per square meter is what we consider. And most of the customers do go for solar panels either now or in the future. So they are ready to go for solar panels. Painting. Now, painting is one of the very important aspect of any steel structure. You know. So we know that steel is a material which can easily get rusted due to atmospheric moisture which is there. So even during transit, if the paint is not done well, transit from the plant to the site, the member gets rusted within a week or 10 days. So painting is something which Interact has consciously gone ahead, and we are using only low VOC paints. What is VOC? Volatile organic compounds. These are carbon compounds which generally vaporize at atmospheric temperatures. You know, they don't need any higher temperature for vaporizing. So even at the ambient atmospheric temperature of 28-30 degrees, these carbon compounds vaporize and they cause gases which are inhaled by the occupants of the building. So we go for paints with low VOC. So that is one of the major steps that Interact has taken in generating a sustainable building. You know. Smart building technologies, we all know, we all have nowadays smart lighting, smart HVAC systems, and access controls, and remote, your monitoring systems, etc. Recyclability. So steel is a material which can be easily recycled. So we can use it again and again. It can be modified, it can be strengthened, the structure can be modified by adding some members, by adding maybe a new floor if the structure has been designed for it, which may not be possible in concrete, maybe, but it will be much more difficult, much more time consuming. Whereas steel is something where you can do these modifications very easily. So the need for making a new steel building is as good as it's not there. You can use the old steel building and do whatever you want by strengthening them, modifying them. So all these are aligned with the principles of sustainable future, basically. Now something about Interact. So Interact is one of the biggest, not one of the, it is the biggest Indian pre-engineered manufacturer company in India. We have been supplying, erecting and producing pre-engineered building from the year 1998. Started full-scale production and supply in the year 2000. Interact has been in the company, has been in India for almost 40 years now, so 40 years. But we moved into pre-engineered buildings in the year 1998. We have sales offices pan-India. We have engineering offices in Hyderabad, in Chennai and our head office Noida. In Noida, we have a strength of about 100 engineers, which includes detailers and our support staff. In Hyderabad, Chennai, we have a staff of about a modest staff of about 20 people. Right? We have 5 plants, 2 in Uttarakhand, 2 in Chennai, and a new plant which has come up right now in Athivaram, which is about 70 kilometers from Nellore. It has just been commissioned now in the year in June. And one more plant in Athivaram will be coming up in the end of this year. So we are expanding. There is a lot of growth for steel industry, pre-engineered steel industry especially. We have sales offices, like we have the head office in Noida, 4 sales offices in North, 3 in the West, 2 in Calcutta and Bhubaneswar, and we have 3 in South, that is Hyderabad, Chennai and Bangalore. About the engineering offices, which I told you. Some of the case studies or some of the projects which we would like to proudly show it to all of our august audience here. This is the Delhi Airport Terminal 3, which was designed, constructed, and manufactured and erected by Intrac. It's the first LEED rated terminal in India, platinum rated as per IGBC, area of about 1,75,000 square meters. This is for a logistic park for Indospace in Luhari, Haryana. Again, this is the first logistic park to be platinum rated as per IGBC guidelines. Again, designed, constructed, erected by Intrac. This is for Tata Motors at Dharwad, Karnataka. Again, a platinum rated green building, area of 72,000 square meters. This is for Hindustan Lever and Assam, Dumduma. Again, a LEED rated building, area of 26,000 square meters. Some of the large buildings which Intrac has executed till date. We have done a lot of data centers in Maharashtra and Gujarat in the north also. Data centers have their advantage in the sense we all know that they carry a lot of load, like 15 to 20 kilonewton per square meter live loads. The speed of construction, because being a steel structure, is very high. So on account of that, your return on investment for the investor is much, much faster. He can move into the building much faster as compared to RCC1, right? Extra space is what you get in a steel building because your beam depths can be optimized. And because you optimize the beam depth, you can probably even add an extra floor within the same height of the building. So that is something which probably in RCC you cannot do. Clear spans, you can have large clear spans. Intrac has done clear span up to 120 meters in the form of trusses, in which the top and bottom cords are built up sections, that is your 3 plated sections, and the diagonals are all made out of hot rolled angles. So we have done structures up to 120 meters clear span. Sustainability, energy efficient buildings, they are of course there, and they can be recycled and salvaged again and again. This is a building which Intrac is again proud to show to all of you today. This is the first of its kind international cooperation and convention center Rudraksh in Varanasi. This has been done in an elliptical shape, if you see, with the ridge somewhere in the center and sloping towards the apex of the curve. We have won 3 awards for that, so I'll be coming to that. We have done JSW steel coated plants in Maharashtra, Karnataka, Punjab. Complex buildings, about ranging from 19 to 45 meters height. This is the largest solar photovoltaic module buildings which we have done for First Solar in Chennai. Area of 160,000 square meters. These are all pre-engineered buildings, designed, manufactured and erected by Intrac. The width of this building is about 300 meters and the length is about 500 meters. And it's a standing seam roof. So 150-meter we have seamed the roof from the ridge towards the eave on either side, which probably is one of its kind in India. Nobody has done a seaming of any roof of this magnitude in India, which was a big challenge, and we have overcome that successfully. The building on the left is for Hindustan Lever at Sumerpur, UP. It's a 63-meter high steel building, a complex steel building, process building, done for HUL. And we have won the EPC award for this as the tallest pre-engineered steel building in India, done by any pre-engineered company. The one on the right is for PepsiCo. It's the largest food plant in India, manufactured in Uttar Pradesh. We have done for Exide Energy Solutions, a huge plant with huge loadings, an area of about 90,000 square meters, collateral load of almost 4 kilonewton per square meter hanging from the roofs. We have delivered the largest robo manufacturing plant in India for Adverb Technologies. These are the awards which Interac has won till now. I mean, one is of course for the Rudraksh building, which I had informed you. We have got 3 back-to-back awards, EPC awards, Construction Week India awards, and the Construction Time awards in 2022. Interac is very particular about safety. We are, as a matter of fact, we are extra particular about safety, whether be it design or manufacturing or erection. So this is a testimony to our the strong safety principles that we follow. We have got certifications from corporate giants like Tata Projects, L&T, JSW, SEAT, Blue Star, Renew Energy, because we have clocked so many millions of safe work hours at our site and in factory. Again, this is the Sumerpur project, the 63-meter high pre-engineered building, which I had shown a few slides earlier. We have won the tallest pre-engineered steel building in India, and also the most outstanding company as a pre-engineered building in India from Mr. Nitin Gadkari. This was last year itself. And I think this is a thought for today, that sustainability is not a choice, but it's an absolute necessity. Thank you so much.
Thank you, sir, for the insightful presentation. Our next speaker is Mr. Gopal Krishna Rao, a civil engineering professional with over 34 years of experience in structural design and execution. He specializes in power transmission, distribution, substations, and renewable energy. Mr. Rao holds a Master of Technology in Industrial Structures from the National Institute of Technology, Surathkal. Recently retired as Associate Vice President at Tractable India Private Limited, he has managed major projects for clients like PGCIL, Adani, and Suzlon. Please welcome Mr. Gopal Krishna Rao.
Hello? Yeah. Hello. Good afternoon to one and all. So many of my colleagues have already covered the sustainability. So I would like to share some of the aspects of sustainability in a different fashion. So let's move on to the topic. Yeah, basically I divided today's my presentation in a 6 part. One is what is CRS steel. It is everybody think that hot rolled is the majority of the steel. So how the CRS steel is formed and what is its versatility of areas of applications and hot roll comparison between the hot roll and cold rolled steel and few design aspects of the cold rolled steel. I am not discussing the equations or anything, just broad outlook only I will cover it. And recycling aspect. Moreover, I would like to discuss a little bit more about the corrosion because that is the one area is giving lot of concern for the complete world. And especially with the reference to the Indian scenario, we have noticed some serious issues about the corrosion in renewable energy projects. Then fire rating and the urban insulation and how it is sustainable. And summing up, I have prepared 2-3 slides. So I will discuss in this fashion. And whatever I am today saying, many of the things are the real life problems. Yeah, you will see that we have got so many steel plants. Few steel plants only will, what is that, manufacture the coils. Yeah. Only few steel plants, integrated steel plants, and some of the mini plants also manufacturing. It will be whatever the cold form steel, it will come as in this fashion. This sorry. Yeah, it will come in a coil formation. So that coils, what we will do? Sorry. Yeah. Just. Okay. This highlighter, right? Please highlighter. Pointer, please. Pointer. Okay. Okay. Yeah, it will come in the form of this coils. So then this coil will be straightened, and once it is straightened and it is decoiled and it afterwards it will be cut into the shape. So then after cutting into the shape, we know the development of the particular CRS steel component. Suppose if we wanted to do different sections, we have to develop the what is the total development length. Based on that, that cutting schedule will go. Then automatically it will run into the series of rollers, and in series of rollers, in the rolling process, it is called cold rolled process. That is why it is called cold rolled steel. And afterwards, it will be automatic direct welding technology is there. If it is a closed section, welding will be there. If it is an open section, directly we will get it. And the quality control and final trimming and cutting of the product, it will come. So mainly the cold form steels, whatever we have seen, most popular is the open type steels. So that means open type means you can see the channels and this rectangle is the closed one And this I wanted to discuss, this is the hatch section. Nowadays, it is very, very popular in total Indian renewable scenario. About 90% of the purlins in solar PV projects are hatch sections, and tracker sections, it is a rectangular hat. These are all very popular sections nowadays are using. So these are all the some of the sections. Hello. Yeah, so if can I remove? Yeah, in a closed section, this is the stages of that rolling process, and finally it will be DTD welded. And if you see the section, you will not find any impressions or any concentration of material or unevenness. So the main important point of this material is this finish is super finish. It is very clear. It is very transparent. If you see either open member or a closed member, the finish is very good, and you can have different colors also, because whatever we are seeing the roof sheeting, you will be seeing the so many colors of roof sheeting is there. And these also we can go for the square sections, hollow sections, and we can get it all this material from 210 grade to 550 grade. Nowadays, all these hatch sections and everything we are getting is a 550 grade. One more point is the main difference between the hot rolled and cold rolled. These are all customized sections. We can get the coils from 640 mm width to around 1500 or 1600. It depends upon the company, manufacturing company, and suppose if you wanted to use for C-section, we will see the way which width suits for us and what is the minimum wastage, and we can mold the customized section for that particular project. See, in hot roll, what will be there? Whatever standard sections are there, we are bound to use. And there are certain thicknesses, and the design, there will be sometimes over design, and sometimes because of non-availability of the sections, we may force to use the higher sections. But here it is not like that. Here, whatever section we wanted, whatever section we finalized, we can manufacture it. Because this manufacturing process also, this manufacturing mission also, it is not so costly. It is available in 30 lakhs or 24 lakhs. Indian companies are there, so many Chinese, Korean companies are there. And these coils also, see, JSW, Tata, or the prime suppliers, SR, nowadays ArcelorMittal steel is coming, and Pasco is dumping lot of material in India, and lot of material is coming from China also. So earlier, in the early stages, most of the coils are coming from the Korea or the China. But now the JSW picked up a lot, and Tata also doing lot of manufacturing. And not only that, some middle scale manufacturing companies also coming with different names and different brands. So here the quality of the cold rolled steel is much controlled than the hot rolled steel, and the tolerances and everything is very better controlled. Yeah, so nowadays this even for the tubular sections also, Few companies are importing these tubes, few Indian companies or popular companies are importing these tubes to many European countries, and they are sticking to the international standards. So the availability of tubes also become more, and nowadays with the CF, with the concrete filled tubes, columns and other things, you can use direct these tubes. These tubes are available right from 1.6 mm thickness to up to 25 mm thickness. Because I am actively working on the tube designs and the tube joints, everything. That's why I'm telling that. So one company is manufacturing 600 by 600 25 mm thick tubes. Now, where we will use, see, now we are seeing the cold form steel. Cold form steel is very much used. All of your mobiles, all the four-wheelers, trucks, truck bodies, truck bodies, bus bodies, two-wheelers, and so many places we are very commonly using this. Sorry. These materials very commonly we are using, and not only that, roof sheeting, cladding, and insulated metal panels also we are using this is very extensively, and deck sheeting for the slabs, and HVAC ducting, and even food products also we are using these things. All these parts, the cold form steels can be recycled. Yeah, these are all the different buildings, all kinds of sectors. It is a tourism, institutional buildings, museums, and everything. It can be done with all these things. And here, it is more largely used in India also in the low-cost housing. Nowadays, 5-story low-cost housing buildings, non-load-bearing insulated panels are used, and if you use it as a load-bearing member, you can go up to 7 floors or 8 floors, and a lot of people are using this one, and especially in the Jammu and Kashmir region and Silatan region, where the seismic criteria is more, where the snow conditions are more, all the defense activities, nowadays it is picking up. So in future also, in the states also, because nowadays we are seeing that there is a lot of shortage of sand. See, now cement is available. We are seeing the huge shortage of sand, and afterwards, in few regions of the country, especially in NCR region, you will find getting aggregate is a difficult. And because of this green concept, and lot of states put ban on the aggregate manufacturing also. So then automatically this construction sector has to look, especially housing sector, to look for an alternative, and definitely this insulated metal panels will have lot of role in future days to come. You can see, as a lot of speakers discussed about this one, so whenever we want, even Narendra ji also told he has already implemented 120-meter large span structures. So these football stadiums, cricket stadiums, all these stadiums you can have it, and this you can have different kinds of roofs. See, what is the shell roof? What is the ideology of the similarity of the shell roof is coming from the leaf, or the whatever the shells we are seeing in the beaches. You see the different shapes of the shells, and leaves with so many internal ridges and formations. This is the basic concept of the shell. Also, you can see the bird nest. That also gives a similarity and configuration, because Anjuriya Saab is telling about what is the similarity between the human being and the structure. Similar way, we can also draw a similarity between a proposed structure, new concept of structure with the natural things. Yes, This is the concept. You can see that it is very much similar to Singapore airport. Changi airport, you can see all the columns are like this. And you see in India what we are doing a very big column, and afterwards we are dispersing into 4 or 6 pieces with kind of attachments and everything. So this is the kind of attachment for the very large column free areas. And similarly, you go to any part, see all the roofs of airports having the very large spans, and they are built with three-dimensional tubular trusses. Yeah, this is the funicular shell. This is nothing but you can see the she shells. Different shapes will be there, different. This is the similarity, and this will be the rib positions. It gives ideas, and it is a monumental shell. This is all implemented elsewhere in the world. You can see the concentration of this thing. And I had been to China. I visited the Olympic Stadium in Beijing also. So it is a nest. The structure is so complicated. Actually, the detailing is very much important. In steel, one advantage is it is a homogeneous isotropic material. Concrete is heterogeneous non-isotropic material. That is why the steel behavior is predictable, provided if it is within the parameters. Within the parameters we'll discuss later. So whatever the shape we are giving, that should be stable shape. We have to make all exercises, whatever the things we want to do, keep the shape stable, then automatically your structure will be stable, your length, you will have a reliability of the section and behavior of the, reliable behavior of the, or desired behavior of the section, we can achieve it. Yes, this was the one of the structure I have designed for 40-meter span with central column. It is already it is 2 years old. It is exactly opposite to the Amazon utility in Fab City, Hyderabad. It is a 40-meter span. That means 20 meter, 20 meter. You can see tubular column 200 by 200, 8 mm thickness. Actually, as per design, 200 by 200 thickness, 6 mm thickness is adequate because the height of the column is something around 11.11 meters, and all the purlins are made up of rectangular tubes. It is 150 by 100 by 2.32 mm thickness tubes. And when you compare with the tube, this tube with a conventional jet design, jet purlin design, the increase in the steel is something around 1.5% or 2.2%, not more than that. But the safety level, the reliability of the section is very much ensured. Suppose for 7.5 meter span, if I wanted to use 3 sag rods, any one of the sag rod fails, my lateral load carrying capacity of the section goes away and the behavior is unpredictable of the jet purlin. Whereas here is 7.5 meter, it is 150 by 100, uska RXX and RY values are very, very good values, and there is no problem about it. Because I had a lot of tussle with the warder and the contractor for adopting this section. Then, adjacent to that, one electrical very big company, I don't want to name the company, they are doing a lot of business there. Their roof was collapsed with jet purlins. Then everybody noticed that, "Arey, hum bach gaya." Hum bach gaya, and then everybody appreciated. And the erector who did the erection work for one of the company for Hyderabad, he called me twice, "Sir, हम निजामाबाद में और एक site है, हमको ऐसा design चाहिए." So that is the requirement. And moreover, I have finalized even with the rafters and everything with the tubes. It's a tubular structure with 2 pipes and 4 pipes also we have done it. And we have put designs in a particular weightage, and with that weightage only we did the everything. And we evaluated and we take the bids for the 4 prominent frontline companies of PEB structures. And the PEB design was controlled by me. Whatever they given, I did not agree, and I have thoroughly seen the parameters, and I have freeze the design, and I freeze the designs for around 150 to 153 tons, and the person who has got 151 ton with the lowest value got the bid, and he has completed the work in 6 months. And not only that, as per international standards, we have provided 0.7 mm thick roof sheeting. For that also there is a lot of debate. So I have checked the complete fabrication drawings. In spite of that, we had a small issue around 5 mm mismatch in the rafter to the column connection. And this was doing extremely well, and you can see the other photographs. So after commissioning, this is a hardware park, their equipment, and it is a completely very controlled environment, humidity, temperature, and everything, and all machinery is imported from USA. And this is the outlook of the structure. So that is why Datta, you may say that, sir, why you are saying that against the jet purlins? Somebody has asked the same question, so many 2, 3 PEB people also. I showed the figures. I will show you the buckling of the sea channels and the jet purlins. Jet purlin, technically it is a very strong one. No issue about the technicality. But when it's come to reality, after 5 years or 6 years, after fatigue or the movement of the sag rod, you will find that elongation of the hole and the efficiency of the sag rod comes down, automatically it leaves. That is the reason why it is not being prominently used in any of the major industrial structures. Now PEB everybody is using. You see the olden days, DCPL or those companies who has done the complete steel plants and everything, they never use it. They use the sag angle. Yeah. Now coming to the comparison between the hot rolled and cold rolled, you can see hot rolled everything is a very thin sections, and section stability is guaranteed. If you are using the hot roll sections, most of the sections, they are stable, they are compact sections, they are bound to develop, they are certain to develop the plastic hinges so that your ductility and the section behavior is very much ensured. Whereas this cold form steel, what will happen is it's a very thin member. It is right from 0.4 mm to up to 8 mm. Generally people are using up to 6 mm, and many of the people are using the 4 mm and 5 mm people for the main components of the building, and 2 mm, 1.3 mm, these are very common for the purlins and other things. Yeah, this is the figure I have taken from INCIDAG only, Datta. Yeah, this is the figure I took it from INCIDAG document only. See, I wanted to show how the geometrical properties will improve for a given weight. See, this is the hot roll section, flange width is 50 and web is 100 mm, and its cross-sectional area is 1193 mm square. Same thing, if you make here flange thickness is 7 mm, web thickness is 5 mm. If you make 5 mm uniform for the C channel, same C channel, and this will come some increment in the moment of inertia and Z and everything. The same thing if you make it 3 mm, these are all the values, increased values. If you make same thing 2 mm, the height of the section is going up to 277 mm and the width of the section is going to 138 mm. There is an increase in moment of inertia around 8.11 times, and section modulus in the major axis is 2.95. Similarly, IYY direction, least that moment of inertia is 10.57 and 3.67. Actually, this is the governing the design, whereas in hot roll section, I am not changing the weight of the member. This main point is here the steel design, we have to use the optimum weight using the better geometrical cross section of the member. This is the main point one has to be observed. And afterwards, when I am doing with the hot roll sections, the flange, outstanding flange ratios, it is around, yeah, where is this values? Yeah, this is around 9, 30, 13 and 15. So for a compact class, these are all the values. Whereas in cold roll, the same values are coming 60. And whereas the web, here it is D by T ratio is around 60. Here it is 150 to 200. So when we are using the cold form steel, the section stability is the most important. That means one is the primary criteria of for the section, behavior of the primary criteria. So the primary criteria of the section is very, very reliable for the hot roll section. In cold roll section, the primary criteria of the section depends upon the secondary issues, that means buckling issues. It could be an axial buckling, it could be a flexural buckling, or it could be a combination of torsion flexural buckling. So these secondary issues will govern the stability of the section. We should take care about that secondary effects. Then only the section will be stable and its behavior will be as per the required level. Yeah, this IS 801 is a very old code. Actually, I don't want to comment on IS. It is very pity. Even 40 years ho gaya and this code is not changed, and all the world is going with limited design. Still, this code is in working stress design. And I am working in renewables right from 2010. From the 5 megawatt project, I am working. So even today, I reminded IS people as well as SCRC, everybody, so many times. Still, we did not receive the new code, but the code is under preparation. Yeah, this is the just the difference between the hot roll and cold form steel, whatever we have discussed only. Only thing is hot rolled. It is a standard section. Whatever section is there, that we have to use it. Hot rolled had some issues with the tolerances and edges and other things. Something has to be smoothened and we have to cut it, and some kind of some scrap value will be little more. Whereas in cold form, its finish is very good. It is just like a mirror. If you purchase a good material, its finish is so thin and it is available in the different colors, different coatings, pre-painted coatings, whether zinc coating or aluminum, aluminum zinc coating or jam coating, and polyurethane coatings and different coatings also there. Yeah, see, that is what I am telling you. How CF is unique. The buckling is the major issue. Buckling is a major issue, and bearing and web crippling. The section, stability of the section should be ensured for the cold form steel. And design may require finite element or strip analysis. This is advanced analysis. It cannot be done with the hand. And highly customized shapes. Whatever, see, suppose I require a different size, whatever shape I want it, I can manufacture it. Only thing is, my machine should have that ranges, whatever the machine, cold form steel machine we are having, that should have capability to form that sections. So, next, I wanted to say something about, very particular about the slenderness ratio. This slenderness ratio is a non-dimensional figure. It's a very important parameter, both hot rolled and cold rolled. The stress levels depends upon the slenderness ratio of that particular member, and the entire stack design also depends on this one. Entire IS 800 or IS 801, everything, all the design stresses and allowable procedure of design stresses, everything is related with this slenderness ratio of the total section and slenderness ratio of the compression flanges. So if you see this graph, you see this graph, as the slenderness ratio increases, your allowable buckling stress will come down. See, if this is for the large slenderness ratio, this will be the magnitude of the sigma y. So if it is a small slenderness ratio, then your allowable value of sigma y will be more. As per my observation, if slenderness ratio is less than 60 or 80, you can allow almost 98 or 95% of the yield value as the allowable value. If it is goes beyond 120, the same thing will come down to 70% or so. If it is goes beyond 150, it will come down drastically. If it is goes beyond 200, even 20% also the allowable value will not come. Because this is one of the important factor to how to maintain the slenderness, how to improve the slenderness ratio is the main task in the design of steel structures. Yeah, I wanted to show some the importance of slenderness ratio. See, this is the tower we have tested. It is around 70-meter height tower. This is the normal height. Up to this height is called the normal height. This is the extension of the tower. This is the large extension is 9-meter height extension. If you see this this angle and in this plane, this partitions and redundant pattern is different. In this hip plane, in the triangular wedge portion, that redundant pattern is different. So both redundant patterns are staggered. It is not concentric, it is a staggered. Because of the staggering, at 95% of the first load, actually the tower will be tested for some 8 to 10 load cases. In the first load itself, we have observed some failure, and afterwards it is increased like this one, and within a fraction of seconds, the tower was collapsed. This was my first tower design in private sector, and it is designed for one steel company. They have already installed one power plant, and to evacuation of the power, we have made this all exercises, and that power plant they have got their own strong design time, and this EPC also tier 1 contractors. I don't want to name it. And after reviewing that, there is no fault in the design. Only problem is this staggered pattern of redundants did not perform, reliably not performed to support the tower. And the same angles we have used it, and we have modified the redundant pattern. Even at 135% of the loading, the tower did not show any sign of failure. Then the company people has called me, Rasab, why don't we reduce the weight of the tower? I did not agree for that. EPC yielded, but I decided I did not. Technically, it is not allowing. See, whatever we are doing, we are getting a bonus because of the proper detailing standards and reliable patterns. So, the detailing of any steel structure is very, very important, and it should be reliable. It should be done with good software. You have to use Tekla, AutoCAD Civil 3D, or BookCAD. Even 1 mm difference in the length of the members will make a lot of difference in the failure of the patterns. So, why I am telling all the things is, even hot roll section or cold roll section, this pattern and the redundant patterns and the behavior of the redundant pattern, the slenderness ratio in a particular level is very much important. Yeah, so with the latest international thing, so all the cold form steel will be checked for axial buckling, flexural buckling, and torsion flexural buckling. The minimum values will be taken, accordingly section will be designed, and our Indian new code will be coming in the same lines. Yes, we are talking about repairability, flexibility for alterations or modifications. That's what I wanted to say. See, this is the one of the substation of PGCL. It is a gas insulated substation. So here water tightness is important, humidity levels is important, and this is made up with superstructure up to 3 meters conventional walls. After that, it is a insulated metallic panels. Generally, as per PGCL specification, 65 mm will be the vertical panel, insulated panel thickness, and the roof panel will be around 50 mm. I don't know whether it's suffixed for the 3 hours fire rating or not. This is a gas insulated substation. Minimum fire rating should be 3 hours. So when we checked for the fire rating of 3 hours in around 15 years back, we did not find a suitable material in India. We are forced to develop 150 mm fiber wool with metallic plates or with kind of bison panel, cement panel board, and those things we have come out with one CSC company. So this is this new sheeting is the new extension, and this one is the old. It was done around 4-5 years back. This was done recently 1.5 years back, and some other party also this same substation they wanted to extend it. So in this portion we have extended around 27 meters in this portion, and this length is around 120 or 150 meters length, so that all steel structures, especially cold form, except the frame, other things, all members are the cold form members, they can be easily extended without, because the entire substation in running condition with all critical weather conditions, humidity and everything. They have maintained it in the same way they extended and they completed, and the project is completed. That means cold form steel, there is no issue of making alterations, repairs or modifications. Yeah, so this is the deck sheeting. You can take the even the capacity of the deck sheeting for the slab design and everything. And this is the wall paneling. It is used as a structural component. That's why all the structural part is fabricated, and afterwards they do the insulations and everything. Yes, whatever may be the structures we are designing, they are subjected to natural calamities. Do you had floods in Rajasthan? Anybody from Rajasthan? Hello, anybody from Rajasthan? कोई है? क्या हो गया लास्ट ईयर? कुछ बारिश ज्यादा हो गया, कुछ कुछ इश्यूज हो गया, हेवी गेल एंड ऑल. Last 2 years, last 3 years, Rajasthan and Gujarat is experiencing the more rainfall. They are treated as a desert regions. Why we are talking? We wanted to see that the global warming should be minimized. That is why we are talking about the green structures, low carbon prints and everything. So the desert area is got last year flood, and last of many of the solar projects were affected. There is a considerable soil erosion. Many of the soil tables were tilted, and many damages to the solar PV projects. And every year, at least in Rajasthan, 15 to 20 EHV tower transmission lines will fail. And overall in India, approximately 80 to 100 towers will fail. Why it is happening? Whenever, especially from June to pre-monsoon period, there is a logic. There is a temperature variations and the climatic conditions. This adds on that. It is not only that, it is not private parties, it is even power grid, even state utilities. Every year it will fall. It's a very common affair. So, in spite of all these things, many things are failing. So, this failure analysis also we have done it. You can see because of the you see the bending, irregular bending. This is the buckling. Maybe it has started yielding. Once it is failed, the failure is catastrophic. Because of the sudden impact, you can find these kind of things. These things are very less in nature. They are there in the hot roll also, but they are in very less in nature. Yeah. So few of the projects recently I visited for some technical due diligence. So in that there are some surprises have come. You can see the some scalings with brown color. This is the early stages of corrosion on the steel members. Can anybody see it clearly? Hello? Am I audible to all? Yeah. See, these are all the buckling failures. You see the strengthening edge of the flanges but it has out of shape. So this is the signs of buckling, and these are all the signs of early stages of corrosion. And you please observe the pattern of the shape and the position of the steel member also. So when it rains, when rain is hitting in this direction, the rain is hitting this, particularly in these regions, probably the wet water or water collected may be accelerating the corrosion process. Yeah, you can see that this is the corrosion traces, and here also some corrosion traces are there. They have painted already. Yeah. These are all the micropiles, steel micropiles used for the supports. You can use concrete micropiles or steel micropiles also. In abroad, in Europe, Egypt and many countries, they don't use concrete because for them concrete handling is a costly affair. They use only steel. So for this kind of tables, the loading on the table is something around 1.5 tons compression. 1 or 800 kg will be the uplift, and lateral load could be around 400 kg and 500 kg. For that, they use the steel. You might be seen when you traveling on the highway, the road barriers, it is simply pushed into the ground. This is same analogy. You might be seeing the LT poles. They don't provide only concrete foundations. They dig it and they will just fill in the concrete. So only some critical locations where there is an angle of deviation or where there is a change in the line angle, then only that point only they will put one stay wire and they will put some concrete, or they ignore that concrete, but they will put some stay wire to take care about the deviation loads. So this, sorry. Yeah, so these things have performed very well, and whereas here you can see the very severe corrosion. So suppose in a plant around 2 to 3% this kind of tables we have observed it. So this plant was commissioned around 2010 or end of the 2010. After 13 years span, and it is around 1 mm thickness material, it is completely, almost I can say it is not useful at all. It is, you can say that it is very badly, one lip is damaged and a lot of corrosions are there. So these are all the main concern for the country, because now our renewable capacity has increased almost 40% of the total generation capacity in India. Earlier, a 5 megawatt project is a big project. Now, it is 500 or 400 megawatt projects you can commission in a period of 4 months. People have did it 3 megawatt project into 4 months from green to commissioning. So that is why we are in a comfortable position compared to earlier olden days. And our target will be 300 gigawatt. Approximately 110 gigawatt or so, now it is added, another 200 gigawatt of renewable energy to be added to the grid. So each, at the time of construction of this plant, we have consumed around 70 metric tons per megawatt. Now the same thing we are consuming around 19 to 18 tons per megawatt. So considering 200 tons of megawatt of power, and the requirement of coal form steel is very huge. The country's supply will not at all meet the demand. So there is a lot of potential for the coal form steel manufacturing in future. So these are all the things, because of the corrosion, it is giving lot of things. You can see, it is not that, it is only few parts of the tables, only 5% or less than 5% and other things. So these projects, behavior is like that, and nowadays with 18 tons or 20 tons megawatt capacity steel consumption projects, what will be the fate after 10 years or 15 years? And what will be the capital? See, in renewable energy project, the cost of civil works is hardly barest minimum. They don't do anything, and it is approximately 8% or so. But the entire project commissioning, IDC of the project, everything will be controlled by this 8% of the capital investment. Yeah, corrosion. Corrosion is a natural process. So there is a proverb in Telugu, I don't know people understand or not. మనిషిలో పుట్టాడు మనిషి మట్టిలో పుట్టాడు మట్టిలో కలిస్తాడు. So we are born in soil and we will immerse in soil after our life. So the same philosophy applicable for the steel also. So the hematite or magnetite, whatever it is there, it is in the form of like a gravel, hard gravel or anything. It will be mined, enriched and processed as a metal. Once metal takes some shape, when it comes to contact with the water or the humid ambient, automatically the ferrous oxides will form, and it is the beginning of the corrosion. This corrosion is very active in marine environment, and where is the oxygen supply is more, this is more aggressive. So that is the reason why we will see many of the pole, many of the supports just above the coping level, you can see the more levels of corrosion. And if water is accumulated for a long period, the rate of corrosion will be more. The same thing, so the corrosion, almost 20 to 25% of the new steel will be going as a replacement of the corroded material in the entire universe. Corrosion is a common phenomenon. You cannot stop it. You can minimize it. How to minimize and how to protect the structure is a challenge, a big challenge. Okay, generally the rate of corrosion will be in a general country like a green area, it will be around 4 microns per year. That means if you have a structure, you need not bother about if the climate is good and good environment, green environment around 200 years. And the same thing in industrial area, it is around 4 to 106. If you take average also, something around 60 microns. That means 16 years for an industrial environment, 1 mm loss will be there. So if a C is there, it will be 0.16. That means 6 years, around 8 years period, you will have loss of 1 mm. So for some of the advanced countries, for some of the important structures, what they will do, they will have corrosion allowance. They always provide 2 mm or 3 mm more than the designed value to take care about the corrosion. Because ours is a very poor country, we cannot afford that kind of cushions. Yeah, these are all the international corrosion classification levels. C1 less than 1.3 microns, C2 category 1.3 to 25 microns, C3 25 to 50 microns, like the CX. These are all C4 and all very aggressive. It is coming around approximately 65 microns per annum. So with this, what is the kind of observations we have seen so far is very alarming. 1 mm thickness in 13 years is giving a lot of alarms. Actually, that purlins are made with 1 mm thick cold rolled steel metal. Yeah, so how to protect corrosion? Because we wanted to conserve the steel, because the steel is a very precious material. If you conserve the old material, its demand for the future will be less, will be same thing, it will be contained. So that is why we will go for some kind of paintings, coatings, and some kind of external paintings also. Yeah, so this is the, whenever you want to do some coating, we have to degrease it, rinse it, pickle it, rinse it, once again rinse it, and flux, any flux or anything is there, it is to be removed. Then after proper drying, then it will go for that particular bath and cooling and inspection. And 1 mm thick either zinc formation or galvalume, aluminum zinc, or any kind of treatment is a challenge, because it requires a lot of sophistication and very good quality control. Otherwise, the structure will be, that member will become like a lot of wrapping will come and member will take wrapper shape. So this is also the, actually the all this process will be a continuous process while preparing the coil itself. Everything will be prepared and come. Yes, these are all the present levels of coating levels. 120 GSM. This 120 GSM means both the sides. Whatever the roofing sheet, whatever we are talking, mostly it will come 120 or something, and 8.5 microns thickness of coating on both the directions. These coatings also they will measure with, there is a separate tool, it will automatically measure it. What is that? Alcometer. Alcometer. And this AZ 150 is very common in India. Many of the 1 mm thick, 2 mm thick sheets, whatever it is available, cold form steel, AZ 150 is very commonly available. And we have seen AZ 150 also some corrosion traces. That is why we would look for something more. This jam material. This jam is zinc, aluminum and magnesium. So a few fractions of magnesium also makes the coating more effective and durable. And you might be reading so many news in the social network. Adani is developing very big solar parks, hybrid solar parks in Kutch region of Gujarat. It is very close to the Indo-Pak border. Similarly, adjacent to that, even Reliance also will be coming with 20 gigawatt hybrid parks. They already commissioned some capacities, or I think 10% or 15% they are already commissioned. The main challenge of that area is it is located in a high seismic zone. And next thing is, it is a very treacherous soil. Some marine clay is there up to 14 meters height, few zones, and high tide level around 2 to 3 meter stagnation of water is there. Because I reviewed their geotechnical reports also through somebody else, and probably I may work on those projects for some other party as a consultant also. It's a big challenge. Working foundations in a liquefaction zone. Can anybody have it? Narenji, working foundations on liquefaction zone. You have to put stone piling for stabilization. It's a very costly affair. It is as good as doing the regular piling. And high saline activity. In the high tide level, the entire water will come as around 2 to 3 meters water stagnation will be there. the approach is most difficult. I think if you anybody following the Google News, you please see around 2 days back the difficulties they are facing and amenities they are providing to the by the EPC companies working in those areas. They are paying huge increments to the new employees for recruitment and other things. So that is the area they are putting like thing, and for that zone, JSW has come up with, they are using the 1 mm thick, I think probably, with jam coated, 350 to 48 mm jam coated material, and they are giving a show light of 25 years. When I contacted JSW, their senior management regarding to share their data, they did not share it. They just they told me that we are developing and it is going, the research is going on, and the results are positive. That's all they told it. So unofficially, what I came to know these figures through some friend circle, I got these figures, and probably jam will be the better coating than galvalume or the galvanization. And this coating is being available with Tatas and as well as ArcelorMittal also. But now the SR steel plant was taken over by the ArcelorMittal group. Yeah, after that there are, you can also apply for the, if it is a minor nature, you can also apply for the ordinary coatings, polyurethane or epoxy coatings also, it can be cleaned and it can be applied. Yeah, now coming to the recycling. So now we have seen the corrosion, how to protect the steel to save some energies. This is a part of sustain, it is also a part of sustainability, and coming to the recycling of the steel. So recycling or the scrap business in the steel in the world is a very big business. So all kinds of, all forms of steel, it can be cut into pieces with cutters and it can be loaded into the, it can be added into the new cycling of the steel generation, manufacturing. Yeah, in steel manufacturing what they will do, they will use, if it is a raw material, it can be clubbed in either blast furnace or electric arc furnace. So in blast furnace, it is a runs on complete fossil fuel. Coal is the firing media and lot of carbon generation will be there, and it is a cumbersome process. It's a very, it is being done in very large processes. You can use scrap along with the other natural materials. And whereas electric arc furnace, you can use the cast iron billets along with the scrap, or you can use total scrap also. So the quality of the metal after recycling depends upon the how we treat the smelting plant and oxidization plant and mineralization process, everything. If you do properly do it, there is no problem for the strength or the performance of the steel. You can do, it is an endless cycle. It goes and comes like that. Only thing one should ensure about the process. And it consumes, electric arc furnace consumes less, certainly 40 or 30% of whatever the fossil fuel in blast furnace. I think the Chand and all they can update because they are regularly working on these things. Yeah, see overall recycling of scrap steel is around 88% in the complete world. It is the most recycled material in the universe. It is the most recycled material in the thing, and 6 cars will give around 2000 SFT house requirement of steel. Whatever the 6 cars, if you read yesterday's paper, business article in Yenadu, if you show the scrap certificate, scrap receipt of your car, that person is entitled for 1.5% rebate on the price of the car, subject to maximum of 20,000 rupees. That means they are encouraging, and the scrap business is a very big business. Unusable scrap nowadays it is trading at 50% of the total cost, total raw material price. If it is a usable scrap, depending upon the availability of that particular section, it goes up to 80%. Last week only, because in my agricultural field, I require one pole. For one pole, I need not go for so much distance and bringing and transportation, everything. I purchased 2 angles. I purchased at 60% cost of the new steel for one pole, electrical pole, and I got it fabricated. So this is my personal experience, and when I wanted to purchase some tubes, they are selling that we will not sell it. We are going to put our sheds, or we are going to develop new factory. For that we require that. Those things I had it near Vizianagaram. So versatility of the repairing. So this is also, say, extensioning or modification, alterations also seen. See, these are all the few projects actually. Sorry. Yeah, wherever the severely damaged, you can remove that piece and you can add new piece of or what damaged piece, where the piece is intact, you can cut it and you can weld it, or you can pin it or like that. Similarly, one more picture. This is a 3 years old project. It is a 3 years old project. I was involved in this one, and this project was developer was sold to some other company. When they were doing the technical due diligence, they find some corrosion in the top portion of the concrete pile. These concrete piles are micro piles only, there is no steel is there. So they supported the panels and they removed it and cut it, and they added another piece of thing and they made it rectified. So this is so versatile in doing the repair or whatever it is there. So nothing is a problem. Had it been a concrete repair, it is not impossible, but it is a costly and it requires a lot of resources and everything. Yeah. Coming to firefighting, I think already Anchuri has covered this one. So lot of panels are available, and one day with insulated metal panels, you can erect minimum 5,000 SFT. That is the yardstick for international standard, and all these panels are as per international building code for thermal insulation, as per NFEA for the firefighting, 1 hour, 2 hour, 3 hour rating, and acoustics approximately 50 decibels. So these things are very much important for the HVC design, and one side it is a U value and other side it is a R value. R value increases with the increase in thickness, and reciprocal is the U value. So you can have corrugated faces, non-corrugated faces. If it is a structural paneling, if you wanted to load bearing paneling, so you have to add the insulated material. Before insulating material, there is a gypsum board, and this is a top gypsum board, bottom gypsum board. This detail is very common if you see any Middle East project. If you see any Middle East projects, they do concreting also same kind of detailing they do it. Because I have developed 380 kV substations for Saudi Arabia and Dubai also, where this is all very common. Yeah, see, you will get all colors, different colors and different things, textures, everything it is available, and it is readily available, just like a AC sheet or the color sheet, you can order it and you can get it. Yeah, coming to what is the basis for, what is the qualities are required for the sustainability. See, steel, any steel, whether it is a hot rolled or cold rolled steel, design freedom and adaptability. So it is an excellent design feasibility which enables the architect and engineers to create innovative and sustainable buildings. So this is a homogeneous, isotropic, most dependable material. A concrete, you cannot say this quality is good. It all depends upon the workmanship. Because it is manufactured in a controlled factory, its quality of the product is ensured. I have dispatched a few lakhs of tons for Africa and Middle East projects. I have never seen single metallurgical or mechanical failure of steel members. Whereas here, when I showed the factory, one steel plate supplied by the Tatas is just exceeded. The carbon percentage is just exceeded. And you know the Indian standards, we have got a very large ranges, anything will pass. So its high strength to weight ratio allows for longer spans and reduced structural members, maximize the usable space and minimize the material uses. That is, it is optimum for the usage. And its strength to weight ratio is very comfortable, very advantageous. And steel adaptability facilitates future renovations, alterations and expansions. Next, energy efficiency. As I told, especially cold form steel, it is very much energy efficient. When we go for the electric furnace, and I read it some article, all the steel industry shall move from fossil fuel to non-fossil fuels by 2030 or so. This was the one steel manufacturer as debated during one of our seminars in Hyderabad. Okay, the lightweight nature of steel allows you the integration of high quality insulation and reducing the heat loss, optimizing the energy consumption for heating and cooling load. This is a very optimum condition or the criteria for the make the energy losses is minimum and better insulation criteria. So that is the energy efficiency based thing. Energy saved potential, steel structures makes the ideal for general building certificates like LEED and BEAM. Nowadays, this is the major concern areas. Yeah, steel is the most recycled material in the world. Recyclability and reduced use. Steel is one of the most recycled material in the world with a recycling rate exceeding that any other construction materials. So this is the thing, and at the end of the building life, steel components can be easily dismantled, salvaged and recycled without compromising their quality. If you salvage any concrete building, you will get a negative value. If you salvage any steel, at least you are assured of, as on today, you are assured of around 40 to 50% of the value of the capital cost. So whoever the developer, he will see the always salvage cost. So the depreciation levels and everything after 30 years, whatever you invested, after 30 years, your salvage value will be the more than your capital, whatever you invested. So when you see the economic vicious circle, it is advantage to the developers. Recycling steel reduces the demand for virgin material, conserve energy and minimize the thing. That is why the recyclability and the reduced waste. Durability and longevity. Steel is renowned for exceptional durability and resilience. That's what we are seeing that. Many steel structures are lasted for 100 years also. If you see the old bridges, steel bridges constructed by the railways and national highways, few national highways, by British era in 19,000, early 19,000, still today they are working. They are unable to replace them. In my area, 2 bridges were built in the 1900th century starting. Now they are damaged and we are facing funds to replace them. It is resistant to pests, rot, degradation, reducing the need for frequent maintenance and repairs and replacements. Yes, it's a durable maintenance, and except the corrosion issues, if you take care about the corrosion, the maintenance cost is very, very minimal. And long span of steel structures minimize the environmental impact associated other issues and making them sustainable. Yeah, steel construction promotes resource conservation. Yes, this is correct. Lightweight, ease of transportation, handling, speedy execution, reduce the waste and minimize the environmental impact. And steel is essential for our society. Yes, in coming future, because of the shortage of the metal, shortage of the sand, certainly people have to move towards the steel for housing also. It is imminent. And due to its structural efficiencies, durabilities and recyclability capabilities, steel is a viable, sustainable material of choice, and its demand is on the rise. So this is my presentation, today's presentation. So if you have any questions, you can ask me. Yes, that is one of the major concern for the renewable projects. That's why I did it. And one more concern also I detected. I don't want to discuss. We are doing some kind of analysis and other things.
Protection.
Yes, you are right. It is very expensive. Ordinary structures cannot bear that cost. That is only feasible for the oil and gas companies, cash-rich companies. It is not because we have faced this problem around 13 years back in Pokhran solar PV project. We faced this problem. We thought of going for it. It is not at all feasible.
Sir, you also mentioned about zinc coating, and there is another technique because corrosion happens due to it is a process of electrochemistry that there will be formation of the cathode and anode within the body.
No, that's what I'm telling them. That cathodic production, it will be done for oil and gas and major water pipelines, but not for ordinary structures.
Can we use sacrificial anodes so like zinc and convert?
Sir, nowadays, if you ask, I don't know whether you have checked thoroughly or not.
Yes, sir.
If you purchase an angle from Raipur Steel, they say 6 mm. You will not get 6 mm. It is 5.2 or 5.6 like that.
Okay.
And the difference between the Raipur Steel and if you purchase from a standard company, approximately 10 to 15,000 will be there.
Okay. Thank you, sir.
Or sometimes it may be 6.4 also. If it is 6.4, he will sell on weight basis. If it is 5.6, he will sell on length basis. So in Vijayawada itself, even reinforcement rods, there are three varieties are there: light, medium, and heavy.
Okay.
So that is why we should always go for a good quality material, so that quality is ensured. Even if it is costly, please stick to quality material.
Thank you, sir.
And this re-rolled steel, with improper processing, you will get cheaper rate. The same re-rolled steel, with proper processing and material control, quality control, it is as good as new steel. Okay? Actually, these steel microtiles are very widely used in abroad for even for medium level and low level foundations. They do this piling only. Okay, I think there are no questions and everybody is tired. Thank you very much for your patient hearing, and very much thankful to INSDAG and as well as the SPV Vijayawada Center for giving this opportunity. Thank you very much, one and all.
Thank you, Bhaiya. So, I will give back my
Thank you, sir, for your enlightening presentation. Before moving on, there are two announcements. First of all, those who had not already registered for this seminar, at the end of the session, the registration desk will open again. You must go and register on spot for your e-certificates. Secondly, there'll be a feedback form sent to your email accounts, and only those who fill up that feedback form will be sent their e-certificates. So be sure to fill that feedback form. Moving on, our next speaker is Dr. Uma Shankar Basina, an esteemed associate professor at the School of Planning and Architecture, Vijayawada. Dr. Basina has over 17 years of experience in both academia and the building industry. He holds a PhD in construction management from IIT Kharagpur and has an impressive track record in sustainable architecture, project management, and large-scale housing projects. Please join me in welcoming Dr. Uma Shankar Basina to the stage.
Good afternoon, all. Yeah, I think Vijay, Samuel Gar, will start. Okay, I hope I'm audible. So yeah, so we'll start our journey. Yeah, I think I can see there. So I'll try to uh, give my views on this particular topic. Our main focus is uh, how steel becomes a sustainable alternative, an eventual sustainable alternative in the near future, or how it is actually sustainable. So that we are trying to look into, try to understand. So can I request your attention onto the screen, please? So we know what is this, right? This is our nation's pride, probably one of the kind in the whole world, which can withstand plus 260 kilometers per hour kind of wind gales, right? And then only steel could make it. And anything, what is sustainability? Basically sustainability is which can lower any waste, any human unwanted activity, so which may put pressure on the natural resources. I think if it can be lowered, then that is sustainable, definitely. So this particular bridge not only raised hope for a large region of people, but also upscaled what can be expected from technology, right? So then we move on, and basically it was a dream and then achieved, so this particular 1.3 kilometers, though it may be just visible, one can always see 1.3 kilometers, but then to move and connect to the other side, people for so many generations had a lot of difficulties. And then a steel as a dependable member could happen, could make it achieve. And then yes, of course, it got inaugurated just June 20th 2024, it got inaugurated. Okay, then actually in this journey, what I'm trying to do, I mean in this presentation, okay, let us see. Can you see this? Can anyone identify this particular structure? Can anyone make it using any other material than steel? It's a museum of tomorrow. So as we can see by the very what is it called? Very celebrated architect. Are you listening? Are you interested? Can we go ahead? Right. So okay. So then the kind of the kind of expression, the kind of identity, what architecture can give to people. See, for example, how many of you have seen Nemo or something like Nemo, that fish movie, right? Even a fish can know that it is in Sydney because opera is there, right? Yeah, people to anyway they know it, right? So buildings or built environment, it can create identities, it can create or it can sustain pride of people, and then this is the kind of setting in which this particular museum has been developed. So okay, I ask you one question: how art can help us be good? If we are smiling, if you are happy, can you think about anything bad? Can it, can anyone do bad when someone is happy? So basically, architecture, good or rather what is appreciable, can actually make people sensible, to their environment, to their place where they belong, and then that it's not just pride; it's a pleasure, So likewise, so now let us. Do you want to get into this building? So what is so special about this? When you even when you are looking for the first time or whatever, can you observe the this particular slide and then this slide? Can you see any difference there? What is it? Yeah, it can fly. See the wings on either side, basically they are dynamic structures. So they can act as wind, what is it called? Basically solar, they can cast shadows, right? And then many ways. And then if you just get into basically what it is, our built form should bring people together for a common purpose, to a common purpose that people can derive pleasure or any other kind, like basically they are happy there, right? So then what kind of structures, what about this? Then if you can actually look into, we are traveling in a timeline, basically we are going a little bit earlier and again we'll come back, and of course it's not just a photo show I want to show. Yeah, definitely not only few. So this, if you can see, is a, of course pyramid is the most stable, but then what else can achieve that kind of a structure than a steel, so then this is, if you can see, 1967, right? So but then it could be achieved. Then the sections, if you can see, can you feel the scale of this project? It's not too huge, but it's reasonably big, right? Because it is holding almost like 522 seat concert hall. The auditorium you have seen there today, what is the capacity, do you know? Close to about 450, 4860, something like that. Now 522, no, you can, kind of scale, right? And then this is in 1967. Now we go back. We all know who is he, right? Basically, why world required large spaces? Why world required large spaces? Because trade is the one that necessitated interactions, so therefore people needed spaces to show cars, interact, sell, buy things. So then are the technologies. So therefore steel was kind of a platform which could give many experimental technologies, so that how we can build dependable large column free spaces, so then we all know now which year we are, 1959. Okay, so then this of course also is, and though he has developed some kind of other experiments as well, now in the 1960s. And then, okay, this is my alma mater. Okay, so now this particular, the main building, can you identify what it is? That particular, this is the same tower. It has actually embedded steel columns and girders, stanchions and girders, right? Steel columns are called stanchions, vertical members. Girders are beams, equivalent. So then now we are talking about 1955. Can you see that? Okay. So then then what about this? We know what is cast iron, the earlier forms of current day. So therefore, this is one of the first of the times when world wanted to have larger exposed Crystal Palace. The Crystal Palace London was kind of, one of that particular time. So huge, almost like 92,000 square meters or something like that, right? It's a huge expo. And then 1851, it was for few. Can you? Of course, I always tell my students you should have a graphical scale, but I myself missed it here. But then it's a huge, like almost like 92,000 square meters kind of a space. It's a huge one, right? And then glass and of course steel, right? Because steel as structural members much thinner, but then that allowed a lot of other area for glass so that more light and visibility can be. Now very quick look, of course everyone knows, but point is steel is the world's most popular, okay, but then so by and large around 1781, life is about experiment. Somebody strikes with a particular, process, and then a process gets repeatable, then it becomes a method, right? A process repeatable, dependable will become a method. Then something like steel as structural members, 1792, and then those are also the times when Portland cement, unless you have cement and steel together in the beginning, right? But then almost the same times 1849, and then we know Otis or this particular elevators. So high-rise towers, So 1852, the first what is it called, multi-story structure, and then Paris Exposition. Then it has many multiple times. Then 1889, that's where the Eiffel Tower was there in Paris. So server asking who designed Eiffel Tower? Who did? Who designed Statue of Liberty? Same person. Okay. So then, okay, now we will come to our cause, right? So now what we see here is the urban population growth in our country, in India. If you can see there, so almost, oh sorry, it's almost from yeah from 19, where are, okay, previous. So if you can see now almost can we hide my. So mind you, this is urban population, not the whole population, which is around 140 crore. So we can relate where we are now, almost close to about 630%, something like that. But then we look into, so here we can see there is a differentiated population growth, mega cities, and then million cities, and then small and medium towns. If you can see, actually the population growth is much larger, much higher in the small and medium towns, wherein as steel, if small and medium rise to, see what is high rise? Anything more than 18 meters is high rise, right? In medium sized towns, if those kind of heights where the steel reinforcement can be, into that, so it may lead to a lot of what do you say, sustainability and less wastage and things like that. Okay, and then let us look into our Indian construction industry. So by and large, what is happening? So second largest employer, where we all are above, we know. But more importantly, construction industry has lot of uh, other connectivities. More than 250 different sectors get, directly or indirectly gets influenced. And then almost like third largest construction, by and large globally will be the third largest. And then if you can see, in February 2024, our Mohua, like Minister of Housing and Urban Affairs, you were mentioning, like there is a fastest growing, because this is our construction is one of the fastest growing in India. Now India, if we have to become a developed country by the year 1947, then infrastructure will be the vital, and then almost like we need to construct something like 700 to 900 million square meters up till 2030. That's a very tall order. If in this case, if we observe, buildings contribute to almost like 28% of, you can see, global CO2 emissions. Okay, so therefore, so then definitely we must see a reason. We must see a way where this CO2 emissions can be lowered. Now, this particular challenge. So, what is the challenge? The challenge is construction and demolition wastage. Okay, so if this particular construction and demolition wastage, if this becomes the highest, the largest trouble, so then almost like we as a country, we generate close to 150 to 500 million tons of construction and demolition waste each year. Okay, so then out of that, if you can see what constitutes of that particular construction C&D waste, by and large, bricks and masonry, concrete, you know, they contribute more or less more than half, that is almost 54% of the C&D waste is of that. But whereas if you can observe, is it visible from far? So metals only constitute less than 5% as the wastage. Okay, so that we have to understand. So, and more importantly, as we are urbanizing very fast, so are we constructing very fast. Okay, so therefore in this particular context, there is a huge demand for methods which can lower this particular C&D waste. So then what else method of construction can be more apt than adopting to steel? Okay, so therefore here, if you can observe, all of this data is related to India, my dears, please you may look into. So this particular construction and demolition waste generation, if you can see from 2012 to upwards, so uh, you can by and large see what is it called, size of the, as per the size of the uh, towns. But more importantly, next slide if you can see, because ultimately this CNW, CND has to be disposed, which would require much larger land area. So therefore, the land area that may be required, if you can see the kind of now we are in 24, so here we are much lesser, but soon there will be more and more 350 square kilometers of urban area. Okay, urban area, which is land is the costliest, whereas that very costly land is also required for the dumping or of this particular C&D waste. So then what is this embodied? So by and large, ultimately sustainability means basically we want to lower the kind of unwanted energy utilization. So therefore we can see that out of all material, concrete, plain concrete or reinforced, you can see the embodied energy is by and large. And then general steel, if you can see, there is a huge. So then, although general steel is that high, but as a steel, percentage wise, in concrete it is less. But later, when we are talking about the recyclability, the actual, what is it called, sustainability aspects can be looked into. So here also, if you can see, we can observe, we can relate the kind of carbon emissions of various building materials with steel 2.7 and all other material apparently much lower, but this is only one side of the story. At this particular stage, it may appear that steel, it may be having much larger, embodied energy or, CO2 emissions. But in a larger picture, let us look into. So, as our esteemed colleagues have already shown earlier, that by and large in the steel production, there are nothing to look into. There are basically two processes. One is there in the steel making. See, first iron is made and then they have to make it into steel. So there are two methods. One is basic oxygen steel making. Another is electric based EAF, electric arc furnace. Those are the two. And then after that again semi-finished products and other things will happen. Okay, that story we'll look into later. But can I please let us focus here. So here if we can just compare basic oxygen furnace BOF, if you can see the CO2 emissions and there is only about 25% only of this, there is only a chance of 25% recyclability only is there in terms of this particular BOF or basic oxygen furnace. But whereas in the electric arc furnace minimum 50, this one is a slightly older one, but almost like 97% or more percentage of recyclable steel can be made part of it, which can make the actual process much more perennially sustainable. Okay, so then that's what I just, so basically EAF, this recycles scrap steel, roughly 20% of energy intensity. So therefore, because by and large energy is what is driving the carbon emissions and many other aspects in our world. So therefore this, and then majority energy. So we have basically 90% of uh, EAF is electricity, but whereas basic oxygen is from coal. So then coal again you have many other related unwanted particulate matters, getting into our environment. So now here direct CO2 emissions in that manner, EAF, electric arc furnace, more or less than 1/3 of that of BOF. Okay, so that we. So then what is the need of the hour? The need of the hour is first to understand. So for what we need to understand in conventional take, make, waste approach, building by and large, my dears, see, any nation, first of all, is a mining country. That's why British or otherwise people went or came here to extract minerals from, Earth's crust or near Earth's, whatever, and in basically mining. And then they took away, maybe some semi-processed or much more, right? So now in this, so first material are sourced and then construction and then there is always a service life and after that it goes to dustbin. That means there is a end of life. Okay, so then it becomes waste. Waste means nobody wants, but then but it is costly to the environment. So therefore again we want to make one more item of the same, again we have to extract from the earth's crust, our mother earth. So therefore it is a perennial depletion that happens of most of the resources. But then that's where the circular economy that has to be brought in, wherein the steel is the manufacturing process, especially after the EAF or electric arc furnace process has started, it could be realized. In this, what is happening? So though in the beginning people have made the basic steel and then they are part of the buildings and then those buildings may reach EOL, that is end of life, but then again that steel will not go as a waste, but again it comes back to the cycle of supply chain to become one more time for the next cycle of its service. So it's like in this manner the cost on natural resources can be much lesser when we are considering the steel as a dependable what is it called yeah building material or much larger than a building material in fact. Okay, so then how lowering of embodied energy in material production, because whenever we need to achieve a larger goal we have to start from the source itself. Okay, so this source itself where so energy production basically and then embodied energy, that's how it comes to usage, and after that operational energy also gets added, and then once it's again what we are repeatedly we are saying, after its end of life, again that material should go back to its manufacturing process. Same again, circular economy, one more time, as a what is it called, structural steel mill, fabrication, construction, building operations, deconstruction, scrap process. Again, so it's like a, but then in this, as everyone mentioned, so now what we see here, see, we are on a Vasudhaika Kutumbam. We are one world. See, in one place, if something is happening, if forests in Amazon are, burning, it's not, it is good for us, right? Its impact is there in another manner, in another location. So therefore, to make it a better world to live on, so then as a whole, people have taken larger, what is it called, resolves, okay? So the resolve is basically here, if you can see, to prepare, to make how greening of steel production, basically, how it can be dealt. So wherein earlier, before the invention of EAF, that is electric arc furnace method of steel making, then it was a separate story. But now we have to, world countries have taken a resolve that that procedure of steel making should be lowered, and then the other recycling from scrap. If you can see, 2050 is a time, or we always put such a target. So is 2047 to be a developed India, right? So likewise, there is a march that is already going towards this particular greening of steel. Now, a look at, sometimes silence is okay. Yeah, when I was listening, I was also impatient, but okay. All right. So now, my dears, we are at a very golden times of our country. Okay, India now is one of the bright spot in the global steel industry. Now, if you can see, is it visible? Is any of the numbers visible? So what we can see, of course, though the first rank is always China, right now 1019 million metric ton per annum, but we are the second ranker at 140 million metric ton per annum steel production. That's okay, but more importantly, what we have to see is where we have started our journey. So maybe this becomes easier to look at. So this particular upper line is China, okay, and then this particular line is ours. So then uh, in 90s we started almost like 5 or 8 or 10 million metric ton per annum to 140. So and then if you can actually observe, almost most countries either have flat growth in the previous years, or in fact negative growth after the COVID. But whereas ours is one of the countries where fortunately we are on a positive growth rate all these years. Okay, so because ultimately, see, each one of you, you ask, will I get a job before you join the institute? Will I get a job? That will depend on what we do after coming here, right? If we don't, so then how? Okay, now so then basically you can see that it's a positive growth, and then we can see here 11.8% year on year positive change. Many other countries actually have negative growths. Okay, so therefore we can capitalize on or so then one more major item here. If you can see, then now we are competing or comparing with the China at 1019 million metric ton per annum. But then if you see, majority, almost 85 plus percentage of their installed capacities are based on BOF, that is blast furnace based production. But whereas if this particular item is 2008, we are not at 2024. In 2024 we are 140. 2018 we are here something like close to 100 only. But here you can see almost 55 or 56 percentage of our installed capacity is on EAF, electric arc furnace production, which is much superior or much more sustainable than the because of course, see, any technology, it's a journey basically. We become better and then we march. Okay, so as a world we are doing that, but fortunately we are on a sometimes. Have you seen this ad? 5-star ad. Don't do anything. Sometimes it may be to our good, right? Okay, so here what it is then, steel construction. So by and large, what we can see, main building material, okay, many things like many of our earlier speakers. So, okay, so average construction processes, modern steel can, what it can offer, material efficiency, because less can be more. Titanium dioxide. Okay, you have taken train journey recently. As a child, how we used to play as a train. Chuk, 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 chuk. You know how the chuk chuk comes? The gap between the rails. What is the length of the rail? Now, can you find the chuk chuk sound? Of course, you may be in an AC compartment, okay? Even if you are not there in an AC compartment, you won't listen that. Because first thing is the length of rails are much more because the steel is much superior these days, okay? So, and also the gaps in between are filled in so that sabotage or somebody forcefully or whatever. But point is technology moves ahead, right? So therefore now, so material efficiency, so that with less we can do more, and then ultra high recyclability. What else? What else can be than steel? Okay, so almost close to 100%, and then quality and durability. When first two are there, automatically the third will be there only if we follow the procedures properly. And then dry construction. Think about how people will live and construct in Cherrapunji. You know what is the coldest place on this earth? There is a place in Siberia called Oymyakon. Minus 71.2 degrees Celsius was recorded. You know what is the temperature generally on the, they stated, on the surface of Venus? Minus 65 degrees. So on our earth there is a place colder than the surface of Venus. People live. They live as like with current technology only. It's not like they are living like no. Okay. Anyway, so therefore life gives. Okay. We need to adapt. Okay. So now here dry construction. So therefore, if such a kind of environment, how concrete can be casted? So therefore, definitely it is that kind of a versatile material, immaterial, irrespective of wherever we are. Probably, of course, there are certain chemicals which can render you useless. Okay, but that is a sabotage. It is a purposeful. Otherwise, no issues. Okay, so. Okay, then the sustainability benefits. Of course, we have to have certain text, so therefore it is there. So by and large, what it is, disposal is, there is no disposable first of all, and then so steel is basically two items. One is iron and recycled steel. So that's what. So therefore, it is an automatic cycle, and then uh, all these many of our, so 93 per structural here, 93%. Okay, all of these, right? And then anything and everything can again go back to the process, and then okay, I'll just go ahead. So then separation, even if something else also, because steel is magnetic, so therefore any doping, any other unwanted material can easily be separated from the steel when before it goes to the recycling process. Now here again some kind of embodied energy data. I don't know if you still have patience to look at, or maybe I don't know if it is visible or not. Okay, so then, so what is advantage? Advantage steel. What is that advantage? Is it visible? Can anyone read? You said visible, na? You read? So by and large, again, it's the same thing. Like, okay, so what it is? So first thing is fast construction, large scale plant, then and then what is it called? Saving of flexibility in expanding, because you can always add on, to concrete, especially with concrete or any cementitious, any monolithic, 1 plus 1 is never 2. You cannot achieve monolithicity with adding another member to a concrete member. No, not possible. Okay. In steel, yes. So then, of course, it is less weight. So therefore, what happens? See, most of the concrete buildings, majority of the thing happens in carrying the self weight itself. Okay. And then suitable with many material. Okay. What is the new change that happened in our trains? Now, railway coaches, have you observed anything? Have you seen any of our older railway coaches and current railway coaches? All of them have become slim. Okay. So self weight is much lesser. So naturally energy consumption will be much lesser. So therefore, if we can identify a root cause, all other things can be aligned much easier in the overall optimization process. Okay. So then, so by and large, our earlier esteemed speaker have already, it's basically steel is in controlled conditions, and then byproducts almost negligible. There are no, I mean, very less. And then what is it called? Continuous innovation, because like EAF emerged, so are the other innovative processes. Okay, so therefore always it is agile. The production process is always agile, wherein better optimization is there. And then increased use of steel, new steel. So therefore what happens? Maybe sometime much larger quantum of steel was there, but now most of it can be just as recycled steel only, not necessarily from the new material. Okay. So then currently over 80% of all steel beams are made from scrap. So basically you don't consume steel. We cannot consume it. It's almost like a renewable material. So basically it comes under that tag now. So then it is possible to make all standard steel grades. Basically, so it is nothing like there is nothing. Have anyone using refurbished phones or gadgets? There may be a tag associated, refurbished. So therefore, in steel there is nothing called refurbished. Anything is new. Okay. So therefore. And then in case of galvanized steel, of course, some processes, zinc and all, they can easily be separated because magnetic properties, and again the rest can still be used. And then, so basically our biggest question. So in the beginning, though apparently it has maximum embedded energy, or it is very costly, but then how this becomes an environmental friendly material? So therefore, so many reasons where structural steel is less harmful. So one thing is longevity and durability, of course, will many have looked into, and then versatility, or it can adapt to situations, scale up, scale down, things like that, and then 100% recyclable, as we are reiterating many times, and then so by and large, and then lower carbon emissions, as we can see, and then no harsh chemicals or toxins in the process. You know Johnson and Johnson's, as babies, many of us. So then that company is struggling now. Why is it? Asbestos, asbestos. Now asbestos itself as a building material was very widely accepted, very economical, but again when people identified that it has certain issues with the very finest pores which can go straight into our lung spaces, our anyway, our ventricles and all, basically less than 1.5 microns, it can straight go, it is like highway to it, right? So but anyway, once new knowledge identifies a new problem, so then certain processes can be red taped, right? Some material may have to exit, whatever. So okay, but so in this case, though, there are not such kind of a risk. And then long economic service life, because by and large we can see steel, because it is so strong, and if it can be coated or it can be sustained. See, World Trade Center, why it has happened? Okay. Why it has happened? Because it did not happen immediately, but it is because there was a fuel. It took time. It gave enough time for people to respond, and then it buckled down, right? So, but again, with having certain systems, steel. So that also we will see. So basically, in our country, like light gauge steel frame structures, as PMAY, Pradhan Mantri Awas Yojana, how we are such a scale that is happening now is mind-boggling. Like nowhere in the world things are happening like that. Okay, so then another aspect is because beam depths. Okay, now the floors, our earlier esteemed speakers. So therefore, a lower floor height, so lower air conditioning loads. All of these are like a it's a cascading effect. Okay, so then long service life. Okay, so by and large, intensive use of space, because more space becomes useful. Then another term. Are you convinced that steel is something to look ahead? So now we will have one more turn. We know what is Ukku. We are the world leaders. Bharat, world leader. Okay, metallurgy. Okay, it is not visible, but maybe 1000 or 12, 2000 years or 1500 years prior to BC, there are many instances which world may not acknowledge, but there are there, right? World may not acknowledge. Okay, so then we all know what it is, right? So therefore, even till date also, with whatever technologies people are having, they do not know the actual composition. Okay, that's okay. Even we also don't know. That is the problem. Okay, so then okay, so but point is like so. But one aspect what we can definitely be know, what we can know is there is a method which can make these forever. The impacts of rest and other things can always be much lesser of time, but we can still come out. So okay, so all right, I'll just so as you can see, this is almost the near few years ago kind of a photograph only. So what we can see, and then in Dhar there is a place in Uttar Pradesh. There also these pillars were found, and then Madhya Pradesh, sorry, and then they were also. So then there is a Vijay Stamba in Bharatpur. It is in So all of these, and then although close to a saline environment in Karnataka, but still, there are instances of proof of India's, leadership in metallurgy. So then, in what way or otherwise we can again, or some that we have to see, and then so are the iron beams, because we know relieving arch above the entrances, and then still, if you have gone to Konark, you might have seen these things, but okay. That is one journey. Then what is now? Okay, so we cannot pat ourselves for our past things. What is now? So then what is modern day steel structural systems? By and large, okay, so as sir has already mentioned, hot rolled steel, and then we have the, so is it visible, the picture? So in hot rolled, by and large, what it may not be a perfect circle. It may be a hot rolled steel would be kind of an oval, because it is cast, because the buoyancy. Do you feel buoyancy? You swim? Eureka. Okay, so therefore when it is cast, the steel in a liquid state, when it is cast, it is not possible to be in a perfect circular cross section. So therefore it will have to have that kind of a oval kind of a shape. But whereas a cold formed steel bar can be, it need not be, but can be formed into a perfect square, matlab circular or any other kind of a cross section, whoever. So basically, if you can see, what are the easier ways? Three easier ways. A scaly and a semi-rough kind of a surface finish, if it is a hot rolled steel, and then rounded edges, and then on what is it called, square rectangular shaped bar stock, and then a non-oily surface. So this can be a non-oily surface. Okay, but whereas a cold rolled steel, by and large, see, cold rolled steel, it is rolled at a room temperature. What is the temperature of magma? We know magma. Magma. What is the temperature? Around 1750 degrees Celsius. Okay. So most of the processes are something around plus or minus to that particular temperature only, whether it is manufacture of glass or steel or this particular cement, you know. So somewhere here and, but then after that process happens, and then cold rolled steel, this is basically at a room temperature. So therefore what happens, it can be shaped into any customized shape perfectly, precisely. Okay. So then what are the easier ways again? You will have like a piece of cake. Your form can be so very, pure, or, and then very smooth surface, and mostly it's an oily kind of a, because they will have to add certain malleable things. So therefore an oily kind of a finish, that sense will be there. So therefore then what are the structural steel frame systems? I will not take much time here because we can straight go. You know what it is? What is this? How many of you are interested? Okay. So basically, any steel structure, any hot rolled steel structure will have vertical stanchions, horizontal girders. Okay. So then, so these are the constraints. See, for understanding, for learning any language, we must understand the alphabet. We must know the alphabet. So then what are the alphabet of this particular structural or steel, using steel as our, building systems? Of course we know, but only we are trying to reiterate. So here, whether it is I sections or H sections or C sections or, L angles or long L angles, and then what are the connects? Now once you have, because all of these are rigid elements, so therefore what else will connect them? Whether so whether it is cleats or, so likewise. So of course we know the system. And then there is another system, light gauge steel frame. So basically the previous one is hot rolled kind of a thing. This one is a cold rolled kind of a thing. So wherein light gauge steel system, have you seen this anytime? What is the biggest problem with concrete, reinforced concrete, or for that matter concrete? Oi, sorry. I take, liberty of saying this. Yes, sir. And anything else in the production itself, sir? In the production, sir? Yes, but predominantly it's a dependent material. It needs form work to become formed. So unless you have form, so that's a lot of unwanted indirect costs which we don't want. It is a waste. So that waste is basically how much sustainable. When we are talking about sustainable, the basic principle of sustainability is eliminate waste. So therefore, why not? Why not? So therefore that qualifies this light guard steel frame structures or any other kinds, of course, but because we are basically for the steel, so this with much lesser lead time, which much quicker ready to use kind of a facility. Because see, these days money is very dear, any investor. Suppose you go to a restaurant, you order something, they are not bringing within 20 minutes. Do you still feel hungry? By the time we get our food, maybe we are not hungry at all. Same is the case in building. Suppose I am having an organization, I am having some manufacturing, I need a office building or other building, I want it in a particular time, but building is taking too much of time, my business will go. My competitor will happily enjoy my business. So therefore, in any of buildings are basically part of the larger business. Buildings are essential for other purposes to support. Okay. So therefore, one needs them to be used at the earliest. So therefore, what else can be a better material than this? Okay. So then still is a code. In case if it is a hostile environment like coastal or other things, then these members can always be coated with some other coating which can, like zinc coating, other coating, so that it becomes, more robust, or things like that. And then the other our from industries as have already mentioned. So basically these light gauge steel frame structures are by and large from the cold formed steel, that we just remember. So these are the alphabet again. How do they look? Okay. So this is one kind, and then once we arrange letters, it becomes words or even sentences. So these are the sentences, right? Maybe a panel which becomes a monolithic, because even in brickwork or otherwise also, even in concrete, what we are trying to do, we are trying to bring in more different constituents unknown to each other, then they all become one monolithic, right? That's what we are trying to do. So here also, though members are there, they have to be assembled together to act as one single, for a purpose, right? Whether it is a partition or a roof or any other, maybe floor. So therefore, so is the case. Okay. So then further, so then depending upon the purpose, and more importantly, there is no wastage. Suppose by chance something happens and then it becomes twisted or whatever it is, then still most of it may be recovered, or otherwise also we may still have a very potent, or higher salvage value, or much different things, wherein the losses are much lesser. It's not like a colossal loss. So then yeah, we'll just so it's simply how much you dream. I will okay, anyway, because can I have a liberty of having a not joke, it's a reality only. There in an institute of higher learning, in a campus interview, a particular person, there are many rounds of interviews have already happened, and then they are very much impressed. They wanted to take him or her, okay. But then actually everyone is okay. But then in that particular room, one maybe he is the chairman and CMD, he is the owner or something like that. He was not talking anything. He was just there. And then, and after all that, all others, they just turned to him, sir. Then that sir asked this gentleman, this person, how much is 1 plus 1? What will you tell? Okay. Then this person said, how much you want it to be, sir? That one is you and the other one is me. Together, how much we can make? Because industry, enterprise, it is people who make things possible. Okay. So therefore, yeah, when people having aligned thoughts can do wonders, something like that. So depending on our need and the kind of constituents we select, there is no limit for any dimension, verticality, horizontality, otherwise. Okay. So then, yeah, then this is the market. You can see, we are seeing the current times. We are not seeing now, we are not at past, we are now. Okay. So you can see 2030 itself, because we are just there, 25 already, right? So then suppose, then what direction we wish to upgrade ourselves? Okay. So then PEBs, okay, sir, as it is not much, So basically again, because people are wanting much dependable, large volume, scale wise, and then better quality control within their spaces. So then this is the kind of market in our India. The previous slide is also in our country, not worldwide. Okay, so here also you can see pre-engineered building market in our country. So we are here. Okay, these numbers I do not know if I can appreciate or not, but what I can see definitely is a positive growth. Okay, so then more and more number of buildings, more and more number of facilities are looking positively towards them, right? So and then okay, there is the alphabet has all elements essential, right? How much we want to combine them, and then rationality. What is rationality? Rationality. Human beings should be rational, right? We must make decisions which are rational decisions. We cannot be foolish, or we should be aware of things, and then we make informed decisions. You know? So therefore here you can see in Mumbai, Navi Mumbai, it's a full scale, what it is? It's a basically mixed use project, hotel and then other office spaces, 100% steel structure, 100% steel structure. Okay, so then it is not far off. It is only it was start 2020. Okay, you can see. Okay, so then with swimming pool, many other things, many other things. So we are not talking about something very futuristic. We are right there already. Okay, so then yeah, it's a very premium kind of an IT space. Okay, so then and then it's a LEED platinum rated building, and then they where they see the value, because they need lesser structural footprint, and then they can have, you know, Mumbai, right? What is the land value of Mumbai? Nowhere else in the world. Okay, so then so is into residential construction. Shrachi, Bengal Ambuja, not Bengal Ambuja, Bengal Shrachi, Kolkata. They are into reality, they are into actual housing projects. Housing projects using steel, they are not small, one floor, two floors, they are tall. You know? So then skyscrapers. So wherein you can see the inside of the spaces also. So they therefore conditioning of spaces, scalability, all of these is already very much. We are very much in how we, you know, what is it called? Empower ourselves so that we be part of this particular growth. You know? And then because the world wants to have certain rules so that we all can become better, or you know, we can be in a dependable place to live. So therefore by 2050, you know, they have got like SDGs, we have sustainable development goals. Likewise, by in a phased manner towards 2050, there are many ways where we can eliminate certain ways. The very reason of why we are having metro or rapid transport systems, you know, instead of personal vehicles, people, we are going to a more mass rapid transport, because it becomes per capita, we are less, you know, offensive to our environment, right? So that's what. So then, thank you, right? Okay.
Thank you, sir, for sharing your valuable insights. Our final presentation of the day is Mr. Rishabh Datta, the convener of today's seminar. Mr. Datta holds a BTech in Civil Engineering from the Indian Institute of Engineering, Science and Technology, Shibpur, and has been honored with the Innovative Student Project Award by the Indian National Academy of Engineering in 2020. He is also a chartered engineer and an accredited professional with the Indian Green Building Council, as well as credited professional of GRIHA. Before joining Instack, Mr. Datta gained valuable experience at Bentley Systems, the creators of StatPro. Please join me in welcoming Mr. Rishabh Datta. Before we proceed with the presentation, we want to present the mementos. If Mr. Sridhar Reddy and Dr. Uma Shankar Basina could please join us. We request Shiladitya Chanda sir to please give the mementos.
Hello. Hello. Long press to off.
Meanwhile, another announcement, those who had not given their email IDs, be sure to give your email IDs at the registration desk. And those who have written their essays can submit it to any of the volunteers you find around, and we'll take the submissions. Thank you, sir. We will now take a short tea break. Please be sure to return within 10 minutes by 5:15. We'll just have the vote of thanks by then. So make sure that you come back soon. Thank you.
Saying mic test. Everybody get seated. Illuminati.
I request everyone to join back in the auditorium.
नहीं आएंगे नहीं आएंगे. यहाँ से अनाउंस करके कुछ होगा. हेलो बेटे आशीष.
I request everyone to please come back and join the seminar.
Hello, hello, hello.
We'll now resume with the seminar. Everyone please settle down quickly. Moving on with the seminar, please welcome Mr. Rishabh Datta on stage for his presentation.
Hello. Am I audible? Yes. So, can we start? So, how's the Josh? High? I think after the tea is like getting high. So, I'll complete my presentation in very short time. So, I think most of the speakers, eminent speakers, has covered all the important portions. So, I don't have anything rocket science to explain to you. Okay. Rather, I will just enlighten some of the points and show you some pictures. That's all. So, my topic is green building and how steel can be a material for green building. That's all. I will not cover anything else. So, that's the only thing I will cover. So, these are the two pictures. Right? Can you see these two pictures? Just raise your voice, yes or no? Yes. Anything you got into your mind that about these pictures? Anyone? Anyone? Please, please. Yes, please. Both are in green color. Okay, that's a fine point. Anyone else? Any points that comes to your mind after seeing these pictures? Because you will get the answer after this. Okay, please. A mic, please. Mic. Mic. Oh, please, please. Please.
One is green by color and other one is green by nature, like plants. That's the difference. Like,
You're from architecture, right?
yeah.
I got it. So yes, so there may be different kinds of answer. I think any more answers? Any more answer? Funny answer? Please. Please hand over the mic.
Sir, actually, something like this will reduce the urban heat island effect. And it's like it accumulates like green energy and it's just not green, it's more about the need for it in the current sustainable environment needs across the world actually, and India is already moving towards it.
Okay, great answer.
Thank you.
Anyone wants to more answers related to this? Anyone from this side? I think we are okay. So I will not give any yes or no answer. Rather, I will show some slides and you will get your answers. Now, what is green building? जो ग्रीन कलर का बिल्डिंग होता है वो ग्रीन बिल्डिंग होता है नहीं नहीं अरे मैं तो वही जानता था अरे यार क्या होता है ग्रीन बिल्डिंग ग्रीन कलर का पर्दा लगाने से ग्रीन बिल्डिंग हो जाता है क्या नहीं ना एनीवन हैविंग एनी आंसर्स अरे इको फ्रेंडली बहुत बड़े हैं आप बताइए और कोई आंसर्स एनीवन एनी आंसर्स मोर रिन्यूएबल इको फ्रेंडली सम अदर टर्म्स चैट जीपीटी पॉल्यूशन रिड्यूस कर दे बहुत बढ़िया और कुछ नहीं ठीक है चलिए देखते हैं अच्छा एक बिल्डिंग है देयर इज वन बिल्डिंग we'll call it as a green building if it is water efficient. अब water efficient कैसे होगा? जो पानी हम लोग यूज करते हैं वो अगर कम बिल्डिंग यूज करेगा, जो बिल्डिंग बनाने में और बिल्डिंग का पूरा लाइफ स्पैन में जो हम लोग यूज करेंगे वो अगर कम होगा एंड एफिशिएंट होगा, देन इट इज कॉल्ड वाटर एफिशिएंट. सो वाटर एफिशिएंट, one of the parameters of green building is water efficient. It is energy efficient also, again the same procedure, बनाने में भी कम एनर्जी एंड पूरा लाइफ स्पैन में भी कम एनर्जी लगेगा. बेटर इंडोर एनवायरमेंट, use environmental friendly materials and reducing building impact on human health. ये सब 5 पैरामीटर रहेगा तो इसको हम लोग ग्रीन बिल्डिंग बोलेंगे. ठीक है, लंबा एक उसका डेफिनेशन है पर आई एम नॉट गोइंग इनटू दैट. सो नाउ हैव यू गॉट द सम क्लू अबाउट ग्रीन बिल्डिंग? ग्रीन कलर का बिल्डिंग में ग्रीन बिल्डिंग नहीं होता है. अच्छा, देयर आर सम ऑफ द बेनिफिट्स ऑफ ग्रीन बिल्डिंग. अच्छा, बिफोर दैट मतलब ग्रीन बिल्डिंग हम लोगों ने बता दिया है, कुछ कुछ बेनिफिट्स होता है, कुछ एनवायरमेंटल बेनिफिट्स होता है, कुछ इकोनॉमिक बेनिफिट्स होता है, कुछ सोशल बेनिफिट्स होता है. ठीक है, तो आप लोग नेट है, इंटरनेट है आप लोगों के पास, तो आप लोग ऑब्वियसली आज जाके देख सकते हैं. मैं और कुछ नहीं बोलूंगा इसके बारे में. ग्रीन बिल्डिंग में एनर्जी भी कम यूज होता है, ये सब नंबर है, तो ये सब नंबर लिखा हुआ है. आई विल नॉट इवन गो इनटू दैट आल्सो. इधर भी और भी नंबर है, इवन आई विल नॉट गो इनटू दैट नंबर्स आल्सो. These numbers are taken from some of the resources and you can look into that resources. So green building हम लोग क्यों बनाते हैं? मतलब हाँ समझ रहा हूँ कि एनर्जी कम लगेगा, वाटर लगेगा, यूज मतलब एनवायरमेंटल फ्रेंडली होगा और अच्छे से ह्यूमन बीइंग रह सकेगा. पर व्हाई ग्रीन बिल्डिंग्स? एनीवन हैविंग एनी आंसर्स? एनी आंसर्स? ग्रीन बिल्डिंग हम लोग क्यों बनाएंगे? मतलब वही है ना, सस्टेनेबिलिटी, एनर्जी, वाटर एफिशिएंट. पर गवर्नमेंट भी कुछ कुछ बेनिफिट्स देता है क्योंकि ये इको फ्रेंडली है. तो कुछ कुछ जैसे हम लोग अगर आंध्र प्रदेश में है तो आंध्र प्रदेश का बेनिफिट्स हम लोग बता देते हैं. देयर आर 2 सच काइंड ऑफ बेनिफिट्स दैट हैज बीन टेकन फ्रॉम आईजीबीसी, दैट स्टैंड्स फॉर इंडियन ग्रीन बिल्डिंग काउंसिल. सम फिक्स्ड टोटल इन्वेस्टमेंट, कैपिटल इन्वेस्टमेंट में कुछ 25% सब्सिडी मिलता है एंड कुछ रिडक्शन इन वन टाइम रिडक्शन ऑफ 20% ऑन ड्यूटी और ट्रांसफर ऑफ प्रॉपर्टी. सो ये दोनों बेनिफिट्स है जो गवर्नमेंट से हम लोगों को मिलता है. ठीक है, ये सम न्यूज आर्टिकल है जो मतलब रिलेटेड टू ग्रीन बिल्डिंग्स एंड ये दैट इज बीइंग पब्लिश्ड इन सम ऑफ द हाई रेटेड इंडियन न्यूज़पेपर्स. नो, ग्रीन बिल्डिंग तो मैंने बता दिया. ठीक है, तो अभी बताइए कि स्टील कैसे ग्रीन बिल्डिंग में हेल्प कर सकता है. अभी ऑल द एमिनेंट स्पीकर्स हैज गॉट सम ऑफ द एनलाइटेंड रिगार्डिंग द एस्पेक्ट ऑफ स्टील, डिफरेंट ग्रेड्स ऑफ स्टील, हाउ द स्टील इज मैन्युफैक्चर्ड एंड ऑल. और ग्रीन बिल्डिंग किसको बोलते हैं हम लोग वो भी पता चल गया. तो हाउ स्टील कैन बी बेनिफिशियल फॉर ग्रीन बिल्डिंग? एनी आइडिया हाउ स्टील कैन बी beneficial for green building? How steel can be beneficial? Let's see. So it is water conservation, less site disturbance, less excavation, non-dusty construction, and recyclability. So just see the points. I will come one by one, no problem. So water conservation में क्या है? मैं 4 पिक्चर दिखा रहा हूं, कोई बता सकता है 4 पिक्चर क्या क्या है? I think all of you knows. Anyone? Just say. हाँ? मिक्सिंग, क्यूरिंग. अच्छा, ये अच्छा ठीक है, तो ये कंक्रीट में होता है, स्टील में नहीं होता है. अच्छा ठीक है, बिल्कुल नहीं होता है. अच्छा होता है अच्छा ठीक है. एनीवन? मिक्सिंग, क्यूरिंग, these are called. सो ये स्टील में नहीं रहता है. स्टील इंटेंसिव बिल्डिंग में फुटिंग में रहता है, लेकिन जो स्टील इंटेंसिव बीम कॉलम होगा उसमें इतना कुछ ये जो कॉलम में क्यूरिंग हो रहा है ये सब नहीं करना पड़ेगा. सो वाटर विल बी एफिशिएंटली लेस. सो दैट इज वन ऑफ द एडवांटेज एंड दैट कैन बी बेनिफिशियल फॉर ग्रीन बिल्डिंग्स. नाउ लेस साइड डिस्टर्बेंस, like some of the eminent speakers are enlightened that steel is capable of taking high spans. ठीक है, हाई स्पैन्स. अगर कंक्रीट में होता है तो कितना स्पैन होता है? इफ वी मेक ए बिल्डिंग इन कंक्रीट, देन जनरल डिजाइन What is the span? You are the architecture guys, so you should tell me. I am from civil background. I don't know anything about architecture. Just general, like you can give any span in concrete also, right? In design. But generally, how much span you give in concrete? Any number? Huh? Minimum? Okay. But for steel, we can go for longer span, many longer span, 10, 12, 15. Okay, so eventually the number of columns will be less. If the number of columns are less, then what happens? What happens? Space is there, footings are less, so eventually आपको ज़्यादा मिट्टी खोदना नहीं पड़ेगा. You have to dig less. So that is one of the points where you will get benefits of green buildings. So एक केस स्टडी लेते हैं, ठीक है? सपोज G+4 रेसिडेंशियल अपार्टमेंट, ठीक है? आर्किटेक्चर समझ पा रहे हैं ना सब लोग? अच्छा, ठीक है. सो दोनों में हम लोग इसको करेंगे, आरसीसी में भी करेंगे, स्टील इंटेंसिव में भी करेंगे. जस्ट वांट टू नो दैट व्हाट इज मीन बाय स्टील इंटेंसिव. एनीवन हैविंग एनी आंसर? स्टील इंटेंसिव, जो हम लोग ये वर्ड यूज कर रहे हैं स्टील इंटेंसिव, इसको मतलब एनीवन हैविंग एनी आइडिया? So steel intensive means the beam columns are made of steel only. So it is called steel intensive. So one having similar plans will make it as a RCC, and similar plan, similar area will make it as steel intensive. So what's the result? You can see the grid plan. One is concrete and one is steel. So eventually in concrete, in RCC, there are 42 number of columns that needs to be accommodated, and total number of columns used in steel intensive is 20. So eventually 22 columns आपका कम हो गया, तो उधर ही आपका खर्चा भी थोड़ा बहुत कम हो गया, स्पेस भी बढ़ गया, आपको कम मिट्टी खोदना पड़ा. ठीक है, तो ये सब ग्रीन बिल्डिंग का पैरामीटर्स आपको थोड़ा बहुत मिल जाएगा इसमें. आईजीबीसी बोलिए, गृहा में बोलिए, ठीक है. ये आपको बताना चाहता हूं, दैट इज बेस्ड ऑन ए हाइपोथेटिकल स्टडी, नॉट ऑन ए रियल केस स्टडी, जो इंसडैग ने किया है. अभी जो नॉन डस्ट है, अब ये दोनों पिक्चर में कोई बता सकता है क्या डिफरेंस है? धुआं और एनीवन? So the left one is the RCC construction that is sometimes dusty because concrete is there, mixing produce some much kind of dust and all, but in steel intensive it is totally kind of dust free. There is no dust produced because concrete ही नहीं है तो dust कहाँ से आएगा, है ना? So ये जो लेफ्ट हैंड साइड में ये जो है ये स्क्रैप है आपका, ठीक है? So you can make building from this scrap also. So it is highly recyclable. As my previous speakers has already mentioned that steel has 100% recyclability. So it is correct. Okay. So I think I have seen the wrong slide. No? Steel, I don't mean चला क्या हो गया ये? हाँ? कुछ गलत हो गया क्या? अच्छा नहीं हुआ. So, ये दोनों पिक्चर में मतलब दोनों आदमी के सिमिलर है या अलग अलग है? सिमिलर है. क्या नाम है इसका? टोनी स्टार्क है ना. और इस लेफ्ट हैंड साइड का क्या नाम है? बोथ आर सेम. सो स्टील इंटेंसिव बिल्डिंग आर लाइक दिस, like tough from outside but green from inside. Okay, now comes for durability. हावड़ा ब्रिज, आप लोगों ने कोलकाता गया है कभी? कोई कौन कौन कोलकाता गया है इधर से? Have you seen Howrah Bridge? I think you must see the Howrah Bridge. Okay, you are from West Bengal, so you have already seen. So it has a ब्रिटिश लोगों ने बनाया था, अभी भी चल रहा है, ठीक है? तो ये क्या मतलब कैसा है? ये बहुत ड्यूरेबल है. ये ऐसे बोलता है कि मैं झुकेगा नहीं, मैं गिरेगा नहीं, ठीक है? और हावड़ा भी जो बोलता है ना, वो बोलता है कि मैं झुकेगा नहीं. अच्छा, ये क्या पोस्टर दिखा रहा हूं मैं? RRR. तो RRR मूवी सब लोगों ने देखा है, बहुत अच्छा है ना? So RRR stands for in movie. Anyone? Rise, revolt and medium में और कुछ है. Rise, roar, revolt. ठीक है? बट हम लोग कुछ और ही बोलते हैं इसको, रिसाइकिल, हाँ है ना, कुछ और ही बोलते हैं हम लोग। तो ये है कॉन्सेप्ट। अच्छा, एक इंदिरा पर्यावरण भवन में हम लोगों ने एक बिल्डिंग बनाया था इंस्टेक से, तो क्या है ना, वो है कंपोजिट कंस्ट्रक्शन। हम लोगों ने एलजीएस से प्रीवियस स्पीकर ने बोल दिया, पी भी बोल दिया। तो एक होता है कंपोजिट कंस्ट्रक्शन। कंपोजिट में क्या होता है, आप लोगों ने स्टील इंटेंसिव के बारे में भी सुना, दैट इज सेपरेट। आप लोगों ने कंक्रीट के बारे में भी सुना। अब दोनों को अगर मिक्स कर दे तो क्या हो जाएगा, दोनों को अगर मिक्स कर दे तो कंपोजिट हो जाएगा। सपोज this is the RCC column, okay, and you embed steel inside, steel I-beam inside, so it will be concrete, composite, okay. So ये ऐसे बिल्डिंग है, ये composite में देखिए आप अगर देख सकते तो ये जो कॉलम्स है, कॉलम में आई बीम है, ठीक है, आई बीम या कुछ और ही बीम है, और इसका जो इनकैसमेंट है वो कंक्रीट से हुआ है, तो ये कंपोजिट कंस्ट्रक्शन है। तो कंपोजिट कंस्ट्रक्शन कैसे होता है, लेट्स अंडरस्टैंड बाय अनदर इमेज, ओके। सो कौन कौन है ये, बाहुबली है, तो कटप्पा ने बाहुबली को क्यों मारा, हाँ? सो बोथ विदाउट देम बाहुबली डिड नॉट, लाइक बाहुबली नहीं बन सकता था, राइट। कटप्पा के बिना भी बाहुबली नहीं बन सकता था, प्रभास के बिना तो नहीं बन सकता था, ठीक है। बट लाइक कंपोजिट कंस्ट्रक्शन इज लाइक दिस, स्टील के बिना भी नहीं बन सकता एंड कंक्रीट के बिना भी नहीं बन सकता। तो इधर मैं नहीं जा रहा हूं कि कौन ज्यादा टफर है, कंक्रीट है कौन स्टील है, वो तो तुम लोग डिसाइड कर लो। और ये कौन है, और डायरेक्टर के बिना बनता है क्या, तो इधर डायरेक्टर कौन बनेगा, आर्किटेक्ट एंड स्ट्रक्चरल इंजीनियर बोथ, ठीक है। स्ट्रक्चरल इंजीनियर के बिना कंपोजिट कंस्ट्रक्शन नहीं बनेगा, तो विदाउट राजामौली आल्सो बाहुबली विल नॉट हैपन। सब यहाँ पे कुछ ग्रीन बिल्डिंग के बारे में, तो ये दोनों एजेंसी है आईजीबीसी एंड गृहा। आईजीबीसी स्टैंड्स फॉर इंडियन ग्रीन बिल्डिंग काउंसिल। आई थिंक ऑल ऑफ द आर्किटेक्ट्स नो अबाउट इट एंड विल बी नोइंग अबाउट इट। एंड गृहा स्टैंड्स फॉर ग्रीन रेटिंग फॉर इंटीग्रेटेड हैबिटेट असेसमेंट, ये बहुत लंबा नाम है। तो ये दोनों हैं, अभी बहुत अलग अलग कंट्री में अलग अलग सिस्टम है, ठीक है। इंडिया में ये दोनों ही प्रिविलेज है, आईजीबीसी है, गृहा है। सो आईजीबीसी में कैसे मतलब what are the steps need that is written over there, and each steps assigned to some of the points, and you will, if you the points, then you will get the IGBC rating according to that. There is some of the process of IGBC rating. I will not go inside into it. You can understand and you can find it in your, well, by Google, no problem. Same for Griha. So Griha rating is also the same procedure, but little bit different from IGBC. So what's the role of IGBC and Griha? Huh? Net zero, right? Net zero तो सब लोग बोलते हैं। तो कार्बन नेट जीरो बाय 2017 हम लोगों ने एक गोल सेट किया है कि हमको बनना है, इंडिया को बनना है। तो कौन हेल्प करेगा हमको, आईजीबीसी और गृहा हमको हेल्प करेगा, ठीक है। So what is the role of an architect? I will not tell anything about that. You will tell me that what's the role of the architect. I will like to hear it from you. What's the role of an architect? Anyone, all of you, please, please. Yes. Anyone else? Yes, please.
नेचर को बचाते हुए बिल्डिंग बनना सर।
बहुत अच्छा आंसर। और कोई? अरे सब लोग आर्किटेक्ट है, यू शुड ऑल आंसर एक्चुअली। प्लीज माइंड विद द माइक।
Sir, do I have to answer in terms of sustainability or have to answer in terms of architect?
You are an architect?
Yes.
So answer this question as an architect.
Actually, according to the current status of India, we have to move towards sustainability because climate has been affected. And if we see the union budget of it, we have been moving towards solar panels and everything. So right now the current need is more towards the durability of every resource, and looking into the matter of all the aspects of materials and everything. So what we can make use of it, like in the old world when people are facing this, Iran, if you consider it, it was the hottest place, but they came up with instant solution to it. We need to look towards it instead of going in one direction of creating something new. We need to look at the complete world and work accordingly.
Okay.
That's what the role is.
So durability should be there.
Durability and responsibility.
Responsibility of the responsibility of the
complete variance of architecture, sir.
yes. So yes, that's a good answer. So as an architect, you have to look, as an architect, you have to look all the parameters, not only the sustainability, but also the cost also. But also because client will ask you the cost. So you have to look for all the parameters. And at the same time, you have to play a role as a like architect to make the sustainable built environment. Okay, my presentation is over. Okay, I have not take much time. So just the information. INSDAG, in INSDAG we held the competition for architect students as well as the civil engineering fraternity also, the students fraternity, each and every year. So you can take participate in that. For that you have to, what you have to go, just visit our website. You will get all the informations over there. Just visit that. And I will encourage all of you to take a part because the cash prize is very good amount over there. And we each and every time 5 teams get selected and get the prizes, and almost we get the participants from all over the country. So I will encourage you to take part on that. Will you take a part on that? Yes. So this is the QR code. Can you just scan it? Is it working? Zoom करके हो रहा है? हो रहा है? Working. So ये इंस्टा का कुछ सोशल मीडिया अकाउंट है, तो आप लोग अगर चाहे तो फॉलो कर दीजिए इसको. जो लिंक्डइन है, फेसबुक है, ट्विटर है, आप लोग फॉलो कर दीजिए. ठीक है? Okay, I am over. So now I will like it is a mine was a concluding session. So always there is a unique way to conclude the session. So I will thank you, and I will. This is my email ID and phone number. If anyone having any questions, please ask. Yes. And regarding your certificates, you will get a survey link. Just take 2 minutes to fill up the feedback form. Once you fill up the feedback form, you will get the certificate after 1 or 2 days. I think you have enjoyed the session. Okay? You have enjoyed the session, right? It has been long session, but I think it was enjoying. Okay, so now we are concluding. So thank you everyone. Thank you.
Thank you, sir, for that enlightening session. Now it's time for a question and answers round. If anyone has any question to ask, please come forward and our experts will be giving you answers.
హలో ఎవరివన్, పెద్దలందరికీ నమస్కారం. సో నా పేరు రాజు అండి. సో నేను మెగాలో సీనియర్ ఎగ్జిబిషన్ ఇంజనీర్గా వర్క్ చేస్తుంటాను. తెలుగు ఓకే సార్? తెలుగు ఓకే? హిందీ? ఐఎమ్ నాట్ ఫ్లూయెంట్ ఇన్ ఇంగ్లీష్, దట్స్ వై. హిందీ ఓకే సార్? sisters. Sir, I have only 3 questions, sir. From the beginning, I write down those questions. Sir, mostly ఆర్సీసీ స్ట్రక్చర్స్ చూసినప్పుడు అందులో ప్రతి స్లాబ్ అనేది మనము ఫిఫ్త్ ఇప్పుడు G+4 ఉంది అనుకోండి సార్, G+4 है तो उसमें लास्ट फ्लोर में देखे तो आप लोगों बहुत गर्मी रहता है नीचे से कंपेयर करें तो. So for PV structures, how the heat can be reduced, sir? अभी कुछ बाहर का बहुत धूप है तो अंदर में स्टील स्ट्रक्चर में बहुत हीट कंजम्पशन रहता है. हीट सोलर पैनल फेसिंग को यूज करे तो भी उसमें हीट होके पूरा अंदर में आकर पूरा गर्मी बहुत होता. So how the heat can be reduced, sir? Because HVAC consumes more heat, more energy to cool the entire area. So that's why.
Yeah, it's only a myth. Now, RCC structures of 30-storied, 40-storied, how they are building it? They are building with a RCC my1 shuttering, right? So that means entire thing is concrete. Only openings have been created with help of some arrangement. So those are more vulnerable for the heat. Steel structure, in fact, with a proper ventilation and a proper steel structure, you cannot do any walls and all. You have to do with the help of aerocon brick or some other brick, right? So that is more, safe in terms of health. It is not the concrete closed environment for any of the building is not safe for your health. You understood? And the topmost floor, generally what we do, so for the underdeck insulation we do. And over and above, generally it is when it's a steel structure and a sustainability, when we are talking about it, generally we go for a solar panels above it. So once the solar panels are there, then automatically your temperature below that, it will reduce. Even if the concrete also, generally topmost floor underdeck insulation will be done. So even for steel structure also, generally it will be false ceiling will be done. And it is not a steel building means it's not only steel. There is always marriage of steel and concrete. You understand?
That's right.
Marriage of steel and concrete only, it can become a complete building. Nowadays, 30-40 storied steel buildings are also designed. How it has been designed? All the cores have been built with a concrete. Then steel structure will be attached to it. Over and above, deck sheet will be there and concrete will be poured. Then only this becomes a complete building. Without the marriage of steel and concrete, a building cannot be built. If it is only steel structure, let us say, without the core, what happens? We'll have to give entire area with a bracing system all around. Then only that building can have a lateral force due to earthquake and wind, it can sustain. So it is very much uneconomical when we are designing only steel structure without the concrete core. Always marry concrete and steel. Think of, don't see that as only steel building can be done or only concrete building done. It is always better to go with the concrete and steel with a steel intensive. What Mr. Rishabh Datta told, steel intensive building has to be designed so that it is a more sustainable building, more economical in terms of recyclability, longevity, and everything. Just now all the speakers have told you, that is the answer for you. Yeah, you can always do that. Always some nowadays theaters, all those things. We are not building the
walls. Sometimes you go with a all with a puff panels only, and the roof also nowadays we are going with a puff panel. We are going with a puff panels only, not for the regular roof need not be a deck sheet. It's only simply galvalume sheet. Puff panels will give some kind of a leverage in terms of a temperature.
Sir, expansion joint అంటూ ఏమైనా ఉంటుందా సార్? Is there any provision of expansion joint more than 40 meter or 50 meter exceeds?
No. For a concrete, it is a 45 meters. Generally, it is a mandatory, but a steel structure, it is 180 meters.
180 meter.
And even 180 meters also, generally what we do, so we have a bracings in between at regular intervals, maybe 30-40 meters, we are going to have a cross bracing, so that your building on the longitudinal direction, it will be taken care.
Yes, sir. Thanks, sir. And one more thing, sir. సార్ ఇప్పుడు మేము సిస్మిక్ జోన్ 3లో మేము కన్స్ట్రక్షన్ చేస్తున్నాం సార్, మాది మెడికల్ కాలేజ్. ఫర్ దట్ జోన్ there is a chlorides and salt contents are more in that region, sir. For that, for avoiding the, if we construct PEB structure over there, what type of precautionary methods we should take, sir, for foundation stage too?
Yeah, okay. So if it is a steel structure, what we need to do is we have to go with the encasement of the column with the concrete, so that it becomes a concrete from outside. Just now Mr. Rishabh, he has shown one building with a steel column encased with a concrete. So that is the more appropriate. So if it is a CFT column, this is the CFT column what we have proposed. That is also you can do, but a regular painting is required. That is also, it can have a both the ways, you can have 2 hours fire rating. If it is a CFT means concrete filled tube. That is also, it can give 2 hours fire rating, but it requires a regular painting. Special painting is required. So always you should maintain it. Otherwise, you can go with an encasement.
Yes, sir.
Mega, you are from Mega?
Yeah.
So we have designed 3 medical colleges for you in Rajahmundry. Rajahmundry, you are the part of Rajahmundry?
No. Machilipatnam, sir.
So we designed Rajahmundry, Elur and Vijayanagaram. 3 medical colleges we have designed in steel structures.
Yes, sir. I didn't get the sir. For CFT columns, we will provide the beams from the column, like adding the base plate.
Okay, probably. So we'll talk one-on-two.
Yeah. Thanks. Thanks.
Okay.
For last words, as a businessman, he have the 1 day of cost is nearly 1 lakh to more 5 lakhs. But he spent time for us. Thanks a lot, sir.
Thank you to all our panelists for the engaging discussion. We now, okay, there's an announcement. If someone has lost their earbuds, please report to the volunteers and state the company's name and take your earphones back. We now move to the valedictory session. I now request Dr. P. Shivaprasad sir and Sir Rishabh Datta to give away the vote of thanks.
Good evening, one and all. I am very much thankful for your presence. On behalf of organizing committee, we want to thank our patrons, Chief Patron, Professor Dr. Ramesh Srikonda, In-charge Director, Professor Vijay Lakshmi, HOD Dr. Srinivas, all our colleague faculty members and staff members. From our co-organizers, INSDAC Kolkata, I wish to thank Director General and Sri Shiladitya sir and Rishabh Datta. And apart from them, I wish to thank all the speakers for accepting our invitation and delivering excellent lectures and topics. Generally, it will take three days of content is delivered in one day. Thank you all the speakers, especially Engineer Sridhar Reddy sir, Dr. Uma Shankar Basina, and Rishabh Datta is also our speaker, Gopal Krishna Rao sir, Dr. Anchuri sir, and Siladitya sir. Thank you all the speakers. And sponsors, InterArch, we are thankful for a industry partnership and we are very grateful for your association. I am very thankful to our support teams, IT, computer science and IT team, housekeeping team, security team, etc. And last but not the least, all the student participants from SPAV and outside SPAV and from industry participants and other university faculty. Thank you all for your participation. Thank you all. So there is a small announcement I wish to make. If anyone wish to make a signature on the registration desk, they can do it now. And also please fill the feedback forms and digital e-certificates will be mailed to you in 2-3 days time from now. Thank you all.
That brings us to the end of this session. Have a very good evening.